extending an invitation to medical doctors of any practice and specialty to apply to the Foundation's private weekly medical teaching workshop. This includes medical doctors, dentists, and veterinarians. Scientists of the Keshe Foundation developed different types of plasma therapies and cures that utilize advanced non-invasive plasma technology. The weekly private medical teaching workshop educates doctors to the plasma science behind the therapies, along with the functionality and operation of revolutionary plasma medical devices. The goal of the private teachings is to add plasma health knowledge to the profound knowledge of medical doctors. The weekly class is broadcast live over the internet through a secure private channel every Wednesday from 2 to 5 p.m. Central European Time. Presently, the class is only offered in English. However, you are free to bring a translator to the class. If you can't participate in the live broadcast, you can watch them later at your convenience through a private internet portal. Every patient's case that is discussed in the workshop will be kept anonymous and private. This includes cataloged findings and data gained from the analysis of the patient's health issues. Any medical doctor in the world who wants to participate can do so by sending an email to doctors@spaceshipinstitute.org. In your email, please state your willingness to participate in the medical teaching workshop. If you're planning on bringing a translator to the workshop, please state this in your email as well. After we receive your email, we will contact you with the instructions on how to apply to the workshop. As a part of the application process, applicants who apply, including any translators brought into the workshop, will be required to sign the Keshe Foundation's World Peace Treaty, which can be found at the following web address. All applicants will be required to provide proof of their education and ability to practice medicine, and will also be required to pass an extensive security background check before they are granted access to the teaching workshop. Healthful plasma technology is here, now, the use of which is increasing exponentially on a day-to-day basis on every continent. We encourage you to come and learn about this revolutionary technology. Apply today.
Okay, Flint, can you share the PPT? Thank you. Next page. Next page, please.
I say go ahead and make your announcement first, please.
Okay. OK， 欢迎大家参加第4次的中文公开教学那么我们今天继续感谢这个 Flint 来主持 Room 的会议，那继续邀请到 Tobin 来参加我们的问答的这个环节，大家有一些问题可以继续提问。那么现在呢我将会对140次的凯斯先生的知识寻求者教学做一个简单的总结，然后呢继续播放我们一些课程中节选的一些关键的内容。
Keshe Foundation Ghana, in association with Ghana Atomic Commission and Ghana Spaceship Institute, would like to invite you to attend the New Dawn, Africa's Meteoric Rise in Spaceship Technology Conference.
We can't see the video.
2016 in Ghana.
Okay, I'm playing it.
The Ghana's over with too.
Yes, I think I mistouched the screen and it played, and I think, wow, you are playing that. I'm not noticed I'm playing that. Okay, can you go to the PPT next page, please? Next, and next, yeah. Okay, so 那么在这个140次教学的是10月6号进行的。那么凯史先生呢，在这个教学中给我们揭开了新的一章。那么他首先告诉我们一些好消息，就是有关这个等离子制剂的话，已经获得了临床许可的应用。在几周之内呢就会有结果。那么他是说，因为之前已经有一些实验的数据，那么所以应该会很快。那么进一步的话也可以继续配合 FDA 和欧洲健康机构的一些认证。那基于现在为止呢，所有的这个毒性的测试都是阴性的。那在这一讲呢，凯史先生真正的将我们带入了太空科技，开始给我们揭示这些UFO 的这些原理。那么他告诉我们用这个风扇的转速的这种变化来检测人体进入等离子场造成的变化，从而确定这个场的边界。那并且告诉我们在2016年的年底之前呢，将会展示 UFO。那么我们是否准备好了接受这样的知识呢？那并且告诉我们说，整个所有这个建造 UFO 的这个过程呢，都是通过这个 Room 的在线展示的，是所有的人都可以同时看到。那么这个分享是平等的。那重点介绍了这个6+12和5+10的这样的一个星体结构的构架。OK, next page. 并且呢有讲到一个新的应用，就是用这种干丝和磁引力场单元放在我们房间的周围，就能够形成温室的效应，就是房间的温度将保持一个恒定不变。那么在这一讲中，凯史先生还回顾了各个时期的反应器的这个发展的历程，从半球到圆球，从最初的气体反应器到这个干丝反应器。那么他说整个这个技术历时了50多年的时间但是他呢在50多个月的时间里将这些技术传递给人类。后面有讲到我们的这个磁引力单元实际上是凯史先生和平系统的一部分。那么他是说他的灵魂是可以与这些所有的系统和人类的这个灵魂相连接的，所以在有可能在某一个特定的时间，它可能会触发整个系统，就是以实现这个人类的真正的和平。并且他讲到他利用了这个大家的小小的贪心，想要制造这个就是免费的能源。这样子，然后所以现在在各个国家，全球的各个地方都拥有了这个磁引力单元。那么就是说它使得它的这个技术能够推广出去。那么给我们揭示了这个金字塔的秘密实际上它非常隐晦的指出，这个金字塔它是在同一个时间，在全球的各个角落就是海上海下都建立了这样一个金字塔。那实际上金字塔的实质呢，它就是在形成一个这个磁引力场，而且呢它实际上是跟外星球这个进行就是这个场的沟通的这样的一个工具。所以这个而且他也讲到我们的每一个这个磁引力单元呢，实际上就是这个一个金字塔和金字塔的作用是一样的。那他有进一步告诉我们说，在有一些用干丝制作的产品像干丝膏、干丝乳液， 这些都已经在欧洲正式开始销售了。它有提到一个水的磁化器啊，可以持续提供碱性水的这样一个设备。那么他有再次就是讲到克劳斯博士所做的这个就是干湿水的测试的这个方法和这些设备是可以用于将来干湿的标准化就是测量这干湿的这个强度场强以及测量就是它到底是哪一种干湿这样子来分析。那么最后呢，他在倡导这个日本福岛核辐射的这些受害者可以去联系凯斯基金会，那么将会得到有关这种辐射的相关的救治。Okay, next page, please. 那我们实际上今天呢会有2部分，一部分是在139次的这个内容呢有2个小段，非常短的2小段，比较关键的一个知识点，我会在这边继续先分享然后就是在做这个140次的这个视频的分享。所以现在我会播放139次的这2段的内容，一个是人类的 DNA 是如何被限制的，另外就是有谈到这个同氨基酸与新氨基酸有什么不同那这2块其实都是在这个很关键的一些知识点。Okay, Flint, so I will play the video and I will share the screen.
Yes, go ahead.
But I forgot. Okay, I see it here. Okay.
Governing is over. Afterwards, to the soul of the man, you doing. So it's nice to watch. The circle.
Okay. Where? Okay.
To the soul of the man, you need to know your soul first, because otherwise you don't have the key. And to know your soul means to conduct the correct way. And then you have the key to the universe. What color spaceship would you like? Man has never understood the power of his soul, because if they would have let him, it would have been a beautiful planet. Many times this has been taught, but because of the lack of communication tools that now we have on the internet, it was buried by those. Then they used it in the name of the priest and the leaders of the religions and the rest of the soul of the man. This is not the first time, but this time we have a tools that every man understands and listens. Last time there was no radio and no television. The problem is the physical interaction, the structure between the gaseous and the physical matter part of this planet, which causes this mayhem and cannot be sorted unless the man understands it and sorts it out himself. Because your DNA is fixed to your planet, and it's the planet which pulls you into crime. The structure of the physicality is too different. It's too high. If you put the amino acid together, and where it comes with the physicality of the matter state, which gives you hemoglobin, which is 56, and the lowest common denominator of your amino acid is 1, it's a huge difference. Energy, and it converts matter in this way, has led to the crisis we have now. Man, the physical man, is a consequence of this evolution of release of energy in such a vast span of the energy field that has caused this problem of what they call animal behavior or killing. The killing is to absorb more packages of energy directly. So if your cap is higher, you need more packages, and you can't receive that package from the planet due to its structure, so you consume. So you consume bigger packages which can satisfy the need of this big gap. The biggest gap is not that the hydrogen is one as an energy transfer to the zinc, which is your emotion level, and around that space. The worst thing is the difference between the iodine and the hydrogen. The potential difference, by order of magnitude of the soul, is so huge that it can change that hydrogen, that it can change the amino acid, that it can change the what you call the DNA. And this process is the problem on this planet. This is our problem. So the only way we can change the man is to show the power of this, what you call the strength of the soul, that it has to give, that it can receive, that it moves the physicality out of the amino acid to a balanced condition of the fairness and absorption of the energy from the universe. That we change the absorption of the energy out of the physicality to the soul of the man. This is what in my teaching I always say. The man needs to absorb, and in a space you absorb energy through the space fields. How can you do it? You have to have a gravitational field which is heavy enough that it can take what you need, and that is provided by the soul. So your savior in a space is your soul. So you have to understand the operation of your soul, how it works, why it works, what is responsible for. And you can walk through the passage of the energy of the universe. The way you touch, you say, this is arm, this is leg, this is my heart, this is my bone, this is my femur, this is my tip-toe bone. But this time, you have to do it in understanding of the fields. And this is what I said in the teaching of yesterday to the doctors. This is what we start teaching you from now. But I always give you a relevant condition with the physicality, because the man has to have something physically to be seen. This is very, yeah, okay. This is the structure. If you have a hydrogen, you have an oxygen, you have a nitrogen, and you have a carbon. At hydrogen isotope, when we talk isotope, we don't talk about number of electrons. We're talking about the strength, gravitational magnetic field in plasma. If this is 1, this is 16, this is 14, this is 12. For copper, we need plus, let's say, 60 plus 16 plus 16 plus 16. This amino acid is still amino acid, but it has a field strength that that in totality, in the combination of the isotopes of the strength of the field, has, let's say, 60, 59, 60, which is copper. For the zinc, the total energy balance is 63 or 65, depends what you look at it. As I explained in other teachings, all the carbons in the atmosphere are not the same carbon. They're of the different strength. They created different way. All the oxygens in the atmosphere ring are not from the same plants, same leaf, different colors, different plants, different isotopes, different energy. So the amino acid which connects to copper has this strength. The amino acid which is with the zinc has this strength. This is the 60 and this is 63 or 65. If the carbon here or the oxygen here goes to the level which you don't even understand, we don't have it in our tables, some of the carbon goes as low as 8, 6. The oxygen goes as low as 8. That's why in that common denominator they have a connection. It's in that level which they find a connection. Not it's just because it's a carbon. The same with the nitrogen. Some of the nitrogen in energy balance goes as low as 8. That's why you find they make the basis of the amino acid. The hydrogen is the release of the balance that they can stay in the strength for this or for this. Here, for example, for copper, we need the carbon to be 8 and the rest say at 16 and 14. But for the copper, carbon stays at 12, but the oxygen goes to 8. So it's different, but even though we see it, because this part of the knowledge of the science of the plasma, especially atomic nuclear, has not been understood because we are in the infancy of the nuclear technology. There's a lot to be understood in the nuclear, or we go as we go to plasma, now we understand the nuclear interaction. And this combination attracts a field which is slightly different than this. And even the amino
Yeah, I think it's a pity that Mr. Keshe didn't finish the explanation for the amino acids difference, but I think it's very important and interesting for this part to know this knowledge. 就是我觉得比较遗憾，就是说凯斯先生讲这个氨基酸这部分哈没有讲完，然后就中断了。但是这部分的知识其实是非常的重要。那么不晓得说关于这两部分，这个小问题的话，大家还有没有问题？那因为所有的这个就是视频呢都在这个创球的网站上都有，那么大家可以详细去看。是不是我这个放到全屏之后，这个字就比较模糊了？那我可能下次做分享的时候，还是把它缩小。那大家如果有问题的话，可以举手，也可以在这个聊天栏，再打出来您的问题。Is there anybody have question for those two parts? If you have question you want to ask, please raise your hand.
In the meantime, Ruthie, you can tell the Chinese friends that when Mr. Keshe is showing here copper and zinc to the initial hydrogen, nitrogen, oxygen, and carbon. Is sorry.
就是你是说凯斯先生在讲这个铜和这个锌它们的不同的时候提到这个碳氮氧和氢
It's to create a possible field.
它们会产生一个场
For the amino acid to do its magic.
形成这个场就是氨基酸的这个场，然后它产生非常奇特的作用。
And that's why he's putting carbon at the last number 4. Yeah, it's carbon, just because it's more heavy. You see.
I remember that Mr. Keshe mentioned in different amino acids and even the carbon or the oxygen or they are different, right? I mean, he means the energy is different, so that's make the amino acids have different energy configuration.
Absolutely, Ruthie. So it's very important to see why Mr. Keshe is putting those elements with copper and zinc, because it transforms and allows this energy to be possible for the amino acid.
对，它就是说，大家可以看到，凯斯先生在讲的时候，在不同的氨基酸里面，它的碳啊、氧啊，或者是氮这些元素，它的同位素的这个能量都是不同的，所以，这也是为什么凯斯先生他在分享这一部分，让我们看到铜和锌，它们都在这个氨基酸它们的氨基酸里面带有不同的这个能量，OK。
There's some questions there in the chat.
Yes, there is a question. Xin Yuenan asked that why when they make GANs, but they got very few amino acid. So how to make a lot amino acid?
It's when it comes to amino acid and the different metals that we're using.
当我们用不同的这个金属去制造这个氨基酸，
you cannot create amino acid on purpose.
你是没有办法说很故意的要去制造这个氨基酸，有目的的制造这个氨基酸。
There is a amount that is depending from one container to another.
它产生氨基酸的多少，有不同的这个容器里面又不同。
And it's also all the time on the top layer in the container.
它总是产生在这个容器的顶层。
And the variation is through the procedure of every time you create a GANs. That's the variation.
不同变化是取决于每一次你制作这个干丝的不同。
Is there a variation? Is there an increase of amino acids based on increase in surface area of the top of the water?
Yeah, so you mean the area is bigger and the amino acid will produce more?
Yeah, that's my question.
Oh, that's your question. Yeah, I think that. Yeah.
So
Yes, sorry, Flint.
Flint 问是说这个容器表面的面积越大，是不是产生的氨基酸就会多一些？然后Tobin 说是的。
Yes, the amino acid once it's collected.
这个氨基酸当收集起来之后
You have the same result as the GANs itself.
跟这个干丝本身的这个结果是一样的。Which kind of result you mean?
It creates once you have a collection of amino acid, then it's behaving like the GANs. They are creating new particles of amino acid.
它一旦你跟氨基酸连接起来的话，那么它会产生新的这个氨基酸的粒子，就像这个干丝一样。
And that is because of the environment of nitrogen, oxygen, and hydrogen.
那是由于这个环境中的这个氮、氧和氢来决定的。
And of course, carbon.
当然也还有碳。
do you have more amino acids if you have a larger surface area or if you use like a bubbler?
It's my experience is that sometimes a container creates a lot of amino acid, and sometimes there is none.
我的经验值也是，有的时候容器里产生很多的氨基酸，但有的时候一点都没有。But why?
It's very I'm not sure why sometimes the creation of amino acid is so much and sometimes so little.
我也不是太清楚为什么有的时候很多，有时候很少。So it's depend on the environment condition, right?
It depends on the environment, and it also depends on if you use your same plates many times, like the copper plates with the nanomaterial on, for example.
Yeah, but if you use it for many time, it will get more or get less.
Yes, for example, when you have never used, or when you use your zinc plate for the first time, then you can be sure you have a lot of amino acid.
哦，他说也跟你这个容器使用了多少次有关系。比如说你第一次用这个来用锌来做这个干丝，他说你会得到很多的这个氨基酸。这样子就是说你用的次数多了，可能氨基酸产生的反而少了，而且呢，它是由这个环境决定的。
Which means that you have to prepare your plates more and more as you reuse them.
You mean replace what? Plates?
When you reuse the plates, you have
Yeah.
to prepare them very well. Actually, you have to prepare them better and better.
Okay.
What do you mean by prepare?
Making sure that the nanomaterial is really off the plate to create new nanomaterial.
Oh, so you mean the even the nano coating material also impact that you have a good quality new nano coating material, and it will maybe produce more amino acid, right?
Yes, but it's not only for the copper and the nanomaterial on. It's also for the plates. It's very hard to prepare. If you used your zinc plate, then it's quite hard to use it the second and the third and the fourth time.
Oh yeah，就是他是说像这个芯板也需要更换，就包含你的这个纳米涂层的这个铜板啊，这个是不是涂层是不是新的涂层做的怎么样？然后如果你的芯板一直是在重复使用，那么也比较难得到这个氨基酸。Yeah, I feel it is that way. Yeah.
It's actually better to have new zinc plates, for example, or new copper is a bit harder. It's more easier to prepare, because what I do is I'm sanding the plates. I'm not only using lemon juice to clean them.
What is lemon juice? Lemon juice is a kind of a liquid chemical to clean the surface of the zinc.
No, it's from lemons.
Oh, lemon. OK， 大
Citron.
概是柠檬酸之类的，就是它不仅它也用一些柠檬酸来这个清洁这个芯板的表面。就是不仅跟芯板有关，但是就是可能纳米这块纳米铜板这块比较容易制作。
But they don't get really clean. It's better to sand them.
呀，他说可能也不一定能够清洁得很干净。Okay, that's great. So if no question for this part, then we continue for the UFO. Yeah.
There's some other long questions there.
No, somebody just copied the main we had main topic we had already talked. Put it here so that people can read. Yeah, 是的，我的网络不太好，因为我 还是在蹭邻居家的网，所以可能有的时候网络会显示就是连接不是很好。那么这个繁星说，他说可能这个新版需要打磨。So is that better to use some sand or something to clean or to how to say that the surface of the zinc?
Yes, fine sandpaper is the best.
Emery
Yeah.
paper.
他就是说比较那个细的那种砂纸去打磨可能会更好。谢谢繁星。Okay, so we can continue for the play the video on 140 for how to build the UFO.
Yes, Ruthie, let's take off.
Yeah, thank you for your answering.
You're welcome. You can also, Ruthie, while it's still time, you can also say that there are ways to create only amino acid from, for example, chicken bones, you know?
所以他说可以从其他的方式来只是获得氨基酸，比如说用这个鸡腿儿，鸡骨头。So you mean use food gums? They also include a lot of amino acid, right?
Yes.
所以就是当我们制作食物干丝的时候，它会含有非常多种的这种氨基酸。
But you see the amino acid that are referred to from the molecules in the air, like hydrogen, nitrogen, and oxygen. That's when you interfere with the copper and zinc. So that's the amino acid that are referred to with Mr. Keshe when he's talking about isotopes and the different reactions from the natural environment. That's very important because those amino acids are the ones that we're using for many sides of the technology.
就是它这个氨基酸amino acid 这个氨基酸它有它的这个碳氧氢它们都有很多的这个同位素。它们多种同位素，然后它们是不一样的，所以就是有不同的作用。
It's the plasmatic environment when you're using especially copper and zinc.
是这个就是特别是像铜或者锌的这个等离子体的场强，你利用的是这个。
The great example is when you have a nano-coated copper plate and a zinc plate.
当你用这个纳米涂层的板和锌板在制作干丝。
And you interfere with some rusty iron close to the either close to the zinc plate.
You mean add some iron into close to the zinc, right?
Yes, you put the rusty iron close to the zinc plate, or actually behind the zinc plate in the salt water.
就是你在盐水中，就是靠近锌或者是在锌板的后面放上这个，应该是铁的 rod 是粗铁是吧？就是还是什么铁？就是放这个铁。So what is wrought iron? Is you mean a stick of iron, right?
Yes, and
铁块 yeah.
And that's to create very adaptable blood.
就会产生这个就是血红蛋白，这是后来这个上节课凯斯先生讲到的。
That's what Mr. Keshe is talking about when he's mentioning the difference between a mix and a match.
所以这个不同就是说是混合跟匹配的不同。
He's talking about the salty atmosphere from the environment, the vacuum.
他谈到这个就是从这个空，这个环境这个空最中间来的，
And and the direct interference with this environment through the rusty iron and the zinc.
就是通过这个铁和这个锌，然后跟环境相互作用。
And you can also say that what people in China is going to have as a result is yeah, go ahead.
就是说在中国，他们做了一些这样的一个结果。
It's going to be reddish, brownish GANs.
就是产生这种像血一样的颜色或者棕色的干丝。
Sometimes it gets exactly like the color of blood.
有的时候那个颜色跟血的颜色一样。
I guess people really want to know about this, right? It's a game changer in the technology.
我想可能人们对这个会非常的感兴趣，这个看起来就是改变游戏规则。
Torbjorn?
Yes.
Does the iron need to be nano-coated?
No. The zinc plate and the iron can either be. It depends on how much GANs you want and actually how much blood you want from the result in the bottom of your container, because you see the interference with because you don't need to necessarily put the rusty iron in the container. You can have it stored so it's nearby the zinc plate.
所以他就是说，这个取决于你想要多少，就是产生多少这个血，类似血一样的这种干丝，然后yes, so
I can actually tell what is happening. Let's say that the description of the environment is referred to from oxygen, hydrogen, and nitrogen, essentially.
这个取决于环境中的这个氧、氢、氮和这个碳。就是说他刚才问的还有一点说他要不要把这个铁也去做了涂层，他说不用。
And the reason why Mr. Keshe is putting carbon in the last position.
上一次开始先是为什么把碳放在最后一个这个过程
it's because it's the heaviest particle next to iron and zinc in your container.
因为它是最重的这个粒子，就是最靠近这个容器中铁和锌最重的粒子。
So when the oxygen, hydrogen, nitrogen, and carbon change in the vacuum, in the air, in the air.
当这个氮、氧、碳、氢在这个 空气中的这些改变的时候。
That's when you have the interference in the salt water with the oxygen, and you steer it around, and that's going to create the possibility for blood to appear.
所以那个就跟盐水中的氢发生作用，然后产生这个血液。
So the simplest way to understand is that when the vacuum gets interference in the plasmatic environment from the container, it interferes with a very special environment procedure through the iron and zinc in a nano state.
You mean the vacuum?
Yes. The air, Ruthie.
The air interfered with the iron and the zinc in the salt, right?
Yes, in the container.
Yeah, 就是空气呢去影响这个容器中的铁和锌 ，and get what?
Blood.
And get blood, yeah. 然后就产生这个血液。
You have to add adaptable blood, because it depends on how you want to use it, right?
Yeah, but what adaptable blood? What does mean adaptable blood? You mean the blood can be used in different way, and how can I get different blood?
No, you there is a slight variation in the GANs, but you can use it for all kind of blood types.
就是说，你可以用在所有的这个场合。
So that's why I'm using the word adaptable.
所以是用一个就是适用的，各种场合的血液。
A better word might be universal blood.
Universal blood. Okay, so no matter you are A and O and B, AB, so you can use that blood, right?
That's excellent, Flint. From now on, it's a universal blood.
Okay, good. 那就是通用的血液。
Just like the base ganses are universal ganses.
就好像我们这种最基本的这个通用的干丝一样。
But it's Ruthie, it's very important here that this presentation from Mr. Keshe has many more sides to it than just to create blood, you see.
就是非常重要的是凯斯先生的这个展示其实不仅仅只是获得这个血这么简单的应用。
One of the important differences is what Mr. Keshe is referring to as green blood, vice versa red blood.
其中一个很重要就是凯斯先生提到的绿色的血液跟这个红色血液的区别。I don't see the green blood. Well, what is green blood?
Green blood is the explanation how the plant kingdom is taking more hydrogen than oxygen through the air and the water.
这个绿色血液是指植物的这个王国，他们如何吸收更多的氢，而不是就是更多的氧气，然后在空气中产生。
And you must tell our Chinese friends, Ruthie, that when they're doing this, when they have a nano-coated copper plate and zinc plate and the presence of iron, they will get this very easy. It's very easy to obtain.
就是当你用纳米铜、锌还有铁放进去的时候，你是非常容易的获得这个血液的。So you mean that blood is also a kind of amino acid, right?
Absolutely, that's the secret. That's the great discovery, that this particular amino acid that you get in the blood, in the result of the container, is absolutely magical.
Is it the same with our blood inside our body?
No, it's that's important to not only create GANs, but every time understand how you're going to use it, how you're going to apply it.
Yeah.
So is it the same or not?
It's going to be the same. You see, that's why the way you imply it is much like the drawing in the beginning of the program. When you see the pen approach,
Yeah.
you take the pen away and you
Yeah.
put a little container of the blood GANs.
Yeah.
You can only approach it to the body, and the molecules are going to take it up.
OK，就是说你基本上也可以把它当做，我在问他说，那这个产生的这个容器里产生的这个血跟我们人体的血液有没有什么不同？他说，基本上是可以这样去用。他就举例说，当我们用那个健康笔去接触我们身体的时候，你可以把健康笔拿走，那么把这个地方替换成像这样的一个这个制造出来这个血液，那么它也是可以跟这个身体去反应的。
It will clean up the. It's a blood cleaner and a blood changer.
它是来清理血液和改变血液的。So you mean that this will very helpful for somebody who has disease of blood, right?
Yes, you can say, for example, that if you have a patient with.
Sorry, 就是他是说，所以我问他说，那是不是这个就是我们制造出的这个血液可以对这个很多的血液病有非常大的帮助？他说是的。Please go ahead.
Yes, if you have a patient with a low presence of iron in the blood.
就如果你有一个病人，他血液中缺铁。
The presence of your GANs will increase the level of iron in the blood.
那么我们用这个血干丝的话，就能够增加病人血液中的铁的含量。
You can also say that when you put a drop of your blood in the inner core, from the torsion field, the inner core and the outer core.
就是
I'm not sure.
You mean when we put our blood into the inner core, right?
Yes.
就是当我们把我们的血液放到这个就是旋转盒的内核，and then what happened?
That's when we actually did this before in this technology. We used the blood as part of the acid.
Yeah, so you mean we can place with the blood GANs to put into the inner core?
Yes.
Oh, yeah. 所以他就说，我们也可以用这种制造出来的这个血干丝放到我们旋转的内核里面去。
And on the outer core, you put pure CO2 liquid plasma.
那么在外核的话，放入纯的二氧化碳的液态等离子水。
This is another application.
What result? What the effect?
Actually, the same thing. You approach with your body when the two cores are spinning clockwise and anti-clockwise.
OK，所以这个他就说也是一样的，它会跟你的身体连接起来，然后当你一个顺时针旋转，一个逆时针旋转。So you mean even that the blood GANs can also connect to everyone's body?
Yes.
就是制造出来这个血干丝是可以跟任何人的身体直接联系的，我们就跟它直接联系上了。所以跟你说用自己的血放进去那个是一样的。But I mean, if I put my my blood into the inner circle, and that means this device can only contact with me. But if I replace with the blood GANs, that means this device can link to everyone. Is that true?
Yes, you see the difference is that the way we have applied this technology, sorry, for some month is the other way around. We're putting our blood instead of creating GAN's blood.
是，就是你看到我们几个月前已经就是把我们自己的血放进去，放到这个内核里面去旋转。
And that has not the same effect. So now that's why Mr. Keshe is saying this is a breakthrough, because you can make such a high quality blood.
因为那个的结果不一样，所以凯斯先生认为这是一个非常大的突破，因为你可以用这种方式制造出非常高质量的血液。
So what we have referred to so far with our own blood is the print, the blueprint from one person.
对，就是如果用我们自己的血液的话，这是一个就是给个人的一个蓝图。
So the DNA in the blood GANs
所以在这个血干丝中的 DNA
is replaced with the very skill of the amino acid.
就非常这种技巧的用这个就是氨基酸替代了。
Yep.
That's great. I think it's a good a lot of application by the, but I think we just open a little bit. Is that true?
The last thing, Ruthie, that you can add is actually to put, if you create 3 containers and you put them in you use the liquid plasma of it in a star formation, it's going to create a very good field.
就是如果你是做三层的这个，然后你放这个液态等离子水进去，然后会产生非常好的茶。
And then you add, of course, the classical liquid plasma, zinc, iron, and copper.
然后你当然你会有传统的这3种液态等离子水，锌、铁和这个铜。Okay, I think we have some other questions.
Yeah, there's several questions here.
Yeah.
Someone's asking about if there's 3 ways to make hemoglobin. How do you detect the purity of GANs? DNA RNA question, and then also Fengji has a question that I brought in that he wants to ask.
Yeah, that's a very good question. It's important, Ruthie, that you translate the fact that when you are creating blood GANs, as I call it, you have to clean it many times.
就是
Wash it.
当你要制造这个血干丝的时候，你必须要清洗很多次，要保持干净。Yeah.
Actually, the more you clean it, the better it is.
你清理的越干净，那么它制造出来的就越好。Okay. So Learn said that human DNA and RNA links to only 10% of the Earth's magnetic spectrum. How to use the GAN's magnetic or gravity device repair the broken links?
I'm afraid I didn't understand the question.
He wants to understand how to repair the broken links in the DNA and RNA by using the Maggrav fields.
Or GANs.
Oh, that's he doesn't have to worry.
Using zinc GANs or iodine GANs or.
Well, you can only create. This is a restricted way to create it. We need iron and rust and zinc to do this in a nano state.
就是刚才他提到说，人类 DNA、RNA 只能连接到地球磁谱的10%。那么，如何用干丝或磁引力装置修复被断开的连接？那 Torben 说他不用太担心。那么我们是用Sorry, could you repeat? I forgot.
Yes, it's only. You see it's only the rusty iron and the zinc that makes this happen in a nano state.
只需要在纳米状态的铁和这个锌就能够达到这个效果。
And it doesn't repair. It doesn't repair anything.
它不是去修复任何东西。
That's the difference between mix and match.
这个不同就是混合跟匹配这两种方法的不同。
You don't create blood GANs by mixing. You're matching the salty environment from the vacuum, and that's how the iron interfere with the zinc in a nanostate.
你并不是去混合什么东西，而是你是匹配这个环境，这个盐的这个环境，所以那个是这个铁跟锌它们的工作机理。
You can tell that the amino acid gets a very very strong field.
这个氨基酸有非常非常强的场强。
It's pure amino acid.
它是纯的氨基酸。Okay.
There's a question here, as far as I can tell, about is there 3 ways to make hemoglobin? Is that what he's asking there?
Yeah, the Lion John asked, is there 3 kinds of method to make a hemoglobin? How to say that?
Hemoglobin.
Hemoglobin.
Yeah, blood. But Flint, can you clarify the question for me, please?
He's asking, is there 3 different ways to make hemoglobin?
No.
Just one.
We have one. I don't, because you see, it's very important here to realize how you interfere with iron. You see?
OK， 他说没有，目前我们就是一种方法。他说你非常重要的是你要知道你如何跟铁去互相作用。
This is a direct link between the salt particles from the environment and the rusty iron.
就是这是一种直接的连接，就是跟你环境中的这个盐的这个微粒，然后跟这个铁，它们是一种直接的连接。
Because when this procedure is allowed to happen, then the zinc plate is going to create, it's going to produce a very different result than the white cloud that you usually get from only zinc.
就是当它们发生的时候，就是这个锌它就会产生完全不一样的作用，就不是像我们原来得到的这个白色的这样的这个就是像云一样的东西，云雾状的东西。
The salt water molecules in the salt water is going to produce more hydrogen than oxygen. That's what.
盐水里面这个分子会产生更多的氢，而不是氧。
this allows the amino acid to get much stronger than previous.
那么这个就是让这个氨基酸比以前的强度更强。Okay.
There's another question up there about how to tell the purity of GANs or how to detect the purity of GANs.
Actually, the purity here is what we refer to from now on, Flint, as the universal blood. You wash it with distillated water.
I think he's asking normally how to detect the purity of GANs.
That depends on the application.
Yes, any GANs, it could be just the zinc GANs or the copper GANs.
Yeah.
How would you detect the purity of it?
取决于你的应用，你是到底是在做这个铜干丝呀，还是这个铁的干丝或者其他？
The purity of all the gases are detected when you stare it, and it looks like a cloud. It should be very, very how do you call it? Velvet. The more velvet it looks, the better it is.
I needed to check the velvet. Could you type it there so that I can look from the dictionary?
Velvet?
Yeah, I'm poor in the words. 它大概是说，就是像云彩一样，就是应该是说特别细腻，还是怎么样？就是像云彩一样的感觉啊，容絮状。Oh, thank you. 谢谢繁星，他说是容絮状的，就是这样子是越好。
When it's easy to stare, as soon as you stare it, you have a cloud.
就是当你马上这个产生的时候，你就像看到像云一样的。
And of course, the color should be very strong as well.
而且这颜色也要非常的就是纯净。But I have a question. When I put the 3 cans of GANs together, I found that my CO2 GANs change color from white to like iron GANs, like to a little bit yellow. So what's wrong with that?
When you mix what?
I put 3 bottles of GANs, CH3, CO2, and copper together inside a big container. I move it. I travel from my hometown to Peking, and when I arrived to Peking, I opened the container. I found that my CO2 GANs change color. It looks like more close to the CH3. I mean that kind of yellow. So I don't know what happened. It was indicated.
That might be particles from the metal that is in the container. You see, you need to. That's why it's important to clean all the gases and isolate them.
Oh, you mean they should be put isolatedly, not put together, even too close, and they will interfere and
Exactly.
go into.
Yeah.
哦，他说，所以像这些干丝的话，他们应该分开放，然后否则的话，他们的场会互相的影响。
You can tell Ruthie that if you want to travel with the gases, then they should be very isolated.
哦，就是所以如果你去旅行，你带着干丝，那这些干丝应该分开放。就是我是说，因为我的干丝带过来，从老家这边带过来，我把它都塞在一个那个容器里面，然后结果就发现我的那个白色的二氧化碳干丝就变红了，就有点那个铁干丝的那个颜色。
So Ruthie, to better understand, I'm just asking, you had your ganses in separate containers, you know, your iron, zinc, and...
Yeah, I have my gas in small bottle,
Okay.
and but I put those together inside a big container, and I take it with me. And when I arrived, I found the CO2 gas became a little bit yellow or red, like
But
the iron gas.
but they weren't physically mixed together. They were still in their separate bottles.
Yeah. I didn't mix it together.
Oh, I see. Yeah. Okay.
Ruthie, you can tell that the ganses are very much like crystals. You see.
就干丝的话，很像这个晶体。
They take from their environment and they clean up the environment.
他们从环境中吸收，然后又释放。Okay, it's interesting, and I heard that some people report that when they get guns, but they put for it's I think it's a copper guns, and put it there for a couple of days, and the color changed to black.
Yes, that happens to crystals as well.
就是他说这个，就是我就说我有一些人好像买了干丝，像铜干丝，结果最后会变黑。然后他说，对，他说就是晶体也是这样子的。
A joke about this is that it's a Ghostbuster.
Ghostbuster? Ghostbuster. Sorry, I don't know a joke.
It's an American movie.
Okay.
I don't know if you've seen it, but yeah.
You see, for me, when people are talking a joke in English, and I always stare at them, what are you talking about? And I can't understand in that way.
It's an American movie about a plasma type solution that neutralizes poltergeists.
OK， 他说就是一个美国电影，谈到叫什么 Ghost Post， 也是谈到那个等离子的一个什么应用啊。OK， so we I think it's complicated.
Deeper into this.
OK, and we still have some question here. I think some people add some question. Yeah. 抓鬼战队，阿基说那个电影的名字叫抓鬼战队。Good， 看起来大家集体的智慧是很强的。谁在讲？请说。
我能提问一个问题吗？
好的，是 Line 张是吗？张老师。
不是，我是房子。
房子，请说。
是这样，刚才问到的这个干丝的这个检测，他是说那个铜干丝有变黑，他说他们也是这种情况，是吧
？I double check with them. Yeah, please double confirm that you also see that happened. The copper gas change color to black. Is that true?
Yes, that's an unstable gas, unfortunately.
他说是的，有发生过这个情况，但是他说那个是一个不太稳定的干丝。
There can be many accidents if the container is not really clean.
他说可能会有好多种情况产生，有可能是你的这个容器并不是太干净。
And it can be chaotic nano-material.
Chaotic.
Not very well nano-coated.
就是说没有涂层做的不好。But I think maybe most of time is because they use electricity and they didn't control well for the current flow. Is that true?
That can also be the cause of it. Very often, when you see when the acid from the from the between the nano state and the metal plate. There's many things, like for example, if you have a zinc plate with a little stain on, that can be enough to turn the GaNs completely black.
Sorry, I didn't understand. You have zinc with what? 有人听明白吗？他说，如果你有锌上面有什么东西，他说也可能会造成这种变黑的情况。
A small little stain.
是这样的，这个因为我们之前也出现过变黑的这种情况，有2种情况，一种是变黑以后，干丝的体积塌缩了，可能原来是一瓶，塌缩完以后只剩下很薄的一层，这是一种情况。另外一种情况是变黑以后，这个干丝的体积并没有塌缩，还是保持原来那种状态。所以我想这2种可能有区别，我不知道就是这种已经变黑这种干丝是否还可以继续使用。
Yeah, Franz mentioned that they have 2 different kind of situation for the GaNs became black. One is that the GaNs became black, but the capacity shrink. It be to a very thin, very thin, and another is the GaNs change to black, but the capacity is the same. They don't shrink. The capacity is the same. So he want to ask is there is a two situation is different, and can those GaNs still be used?
I don't think that's a good idea. It's better, you see, it's better to redo the procedure, because the unstable GaNs have a very intricate story.
就是他觉得可能最好不要用，因为这个不稳定的干丝的话，它可能会有各种变化。
The stability is when you have the silky stable color.
对，就是这个稳定的话，就是你必须要有像这个是 silky 丝状的这种很稳定的这种颜色。
It's better not to use it really.
OK， 他建议
是这样的，我们现在都用那个蒸馏水来清洗这个氧化铜干丝，然后我们现在发现呢，这个用蒸馏水清洗过的这个干丝呢是一直都没有变色，就是氧化铜的干丝。
Yeah, but they also found that if they use the steam water to wash the GaNs, and the GaNs never change the color. So maybe sometimes it's also because the water maybe it's not pure, and it causes the GaNs change colors.
Absolutely. Before people throw it away, they could give the GaNs some time. Very often they come back to its original color.
他说是这样的，就是用蒸馏水洗会比较好，而且呢，他说当你在你把干丝扔掉之前呢，他说你给这些干丝足够的时间，也可能这个干丝它又会变回这种颜色。It's interesting.
Yes.
网上有很多网友，他们是把那个干丝用醋或者是酸来加入，然后发现这个干丝呢会溶解掉，会消失掉。请问一下，他们对这种现象应该有什么看法？
我记得我们以前问过一次凯斯先生，然后但是凯斯先生那时候解释的，我觉得我也没有完全弄懂。那我们再问一次。Yeah.
好，再问。
Yeah, Franz mentioned that some people add acid or add alkaline water into the GANs, and some of the GANs disappear or it decrease. So how do you explain this kind of
Well, there. As soon as you start to mix the gases, then sometimes you can get lucky, and sometimes it's just another GANs. So it depends on how you want to use it.
No, we just because somebody think that GANs should not be resolved in acid liquid, but I think it's not true, because when we made food GANs or something like we add the acid inside it, and later we add some alkaline inside it, and then the GANs come out. So I think we still lack of the knowledge to understand how GANs are made by add acid or add alkaline, and when people make the Chinese traditional medicine GANs, and some from the food, and they found that when they some of the material they should put acid inside it, and some of them should put alkaline inside it. So it's different. So we don't know how and why it's like this.
Well, very often when you add to the GANs particles in order to have a more stable pH value, then the product is not clean. The product to obtain the pH value.
I think what she's asking here is completely two different things.
Okay.
The base GANSes, the copper, the iron, zinc GANSes, those are made with plates that are nano-coated copper and then a metal of each. That's made with, best ones are made with no electricity in a saltwater solution and so forth. What she's asking about is, I think, the food GANSes. And with the food GANSes, those food GANSes are typically made by replicating what is being done in the human stomach, by adding an acid, breaking it down, neutralizing it with the alkaline solution, and you get your GANs. So I guess the better question is, what's the best way to make food GANs?
Well,
yes.
Yeah.
I just make it clearly more clearly. It's because that I think for the food GANs, different plants, they are some of them, I think they are acid, and some of them are alkaline. So I think maybe just because this, so when we make GANs, we put sometimes we put acid inside it, and sometimes we put alkaline inside it, and to make GANs. Is that true? Based on the properties of the food.
Yes. Fortunately, actually, the different GANSes, food GANSes, have really different charges, and it is very hard sometimes to get food GANs that is pure liquid plasma.
所以就是这个食物干湿的话，其实它是另外一回事情。很多时候它不是，它不是像我们之前像盐水做的这个样子。
It depends on the amino acid and the charge of the amino acid.
它是取决于这个氨基酸对它的充电来造成的。
Well, I've seen it made both ways. You know, I've seen Brennan makes his food GANs with caustic, with NaOH. And Jackie and others have made food GANs with lemon juice, which is acidic.
Yep.
But if you make it with the acidic, then you have to heat it up to 100 degrees Celsius. Not Celsius, 23, 24, I don't know what it is in Celsius, the temperature of the human body, and cook it for 20 minutes, and then you get your GANs after that with using the acid way, right? So it's, if you're using acid, you're using heat.
哦，所以
Because
wait, let me translate. Oh, I forgot. Thank you. 所以Flint 是说他看到不同的人他做的方法不同，然后呢，那个Raylan 他们呢是用碱液来做的，那 Jackie 呢他又是用酸来做的。他说当时用酸的时候，他们用加热，他会煮上20几分钟，然后放进去酸，
In both ways, you're using heat, because in the caustic method, you're using the food chopped up in very small pieces or ground up, putting in your water, your hot water, and then caustic, and letting it react for several days or several weeks till it's broken down. And then Brennan always uses that resulting solution without washing it, because he only uses food GANs in patches. But if you want to use it in another form, then you have to wash the salt water out and everything. But with a regular acid method, maybe you can ask Monique what's the best way to do food GANs.
Yes, Monique has a procedure where she doesn't use any acids or heat.
他是
Can
说
I add something, perhaps? Hello.
Oh, good. Hey,
Hello.
Jackie. Oh, good.
Hey, it's good that you are joining with us.
Perhaps I can tell you some stories regarding the food GANs, how the different methods appears.
Okay.
Wow, that's so great. 所以他是说每个人做的方法都不同，然后 Raylan 做的就是用这个碱，然后这个 Monica 有的也什么酸都不用，就是说，然后 Jackie 他又会有不同的方法来做这个食物干丝。Okay, so Jackie, could you share with us some?
Yeah, perhaps just I'd share the black screen. So
Okay.
the first who was speaking for the food GANs was how it's named, Alex from Nigeria.
Okay.
And his
Alex
method,
从尼日利亚的这个方法 ，OK，
he simply take his CO2 kit.
他只是用这个制作二氧化碳干丝的这一套东西。
And when the production of this CO2 kit starts, he just add the food particles into the CO2 kit.
他只是把一些食物的这个微粒放到这个二氧化碳干丝的制作设备里面。
So it transferred the energy of the food into the container.
他把这个食物的能量就传输到这个容器里了。
Then this is the first method. The second one was Carolina de Rose.
第二个方法是用碱液的方法。
Saying that you can take your food, you mix in small particles.
你把食物弄成非常小的微粒，
You put in a container your particles.
你把它放到一个容器里面，
Then you add some NaOH, caustic soda.
然后你放一些这个氢氧化钠在里面，
You add boiling water,
然后加这个热水、开水，
and then you let make the process 2 or 3 days,
然后放2-3天，
and then you wash the liquid, and you add new distilled water into it.
然后你去清洗干丝，加入新的这个静态水，或者是蒸馏水。
So this is the method of Carolina. Then Renan and Verny play a lot with this.
这是 Verny、Renan 他们就是用这种这个碱液的方法来做。
Then the third method was Arvis Liepa, liquid plasma. Try to replicate the digestive system.
Artist is a person, right?
Yes,
Yeah, or Latvian.
you
They're
can
from-
find a lot of things in liquid plasma on the
Okay.
site of Facebook, liquid plasma.
Okay.
You will
另外
find different method.
OK， 另外一个人是 Arvis 的方法，那么可以在这个 Facebook Liquid Plasma 里面找到他分享的很多内容。
And he replicate his idea. He wants to replicate. So he said, your food GANs, you need to applicate 37 degrees because it's the temperature of the body.
OK， 所以他是完全想要复制这个食物在我们人体里面的这个过程，所以他要求是37度的水，37度。
Yeah. So he cut the food, put in a container, put a little water, and boil it on the fire to obtain 37 degrees.
OK， 所以他是把这个食物放到水里，然后底下用火就是加热到37度。
Then, like in the body, the first step it's you put your aliments, your food, in a very alkaline solution. Like the first digestion, it's like a nano coating. So it puts some NaOH into the solution.
然后把它放这个氢氧化钠放进去。
He let for some hours.
然后让它待几个小时。
And when the food come into the stomach of the man, the stomach contains hydrochloric acid, HCl is hydrochloric acid in the stomach of the man.
就是然后人的这个胃液里面呢是含有一些这个酸HCl。
So when you add the HCl into the solution, you release all the energy you have kept there. So it's a big release of energy there.
所以这个时候你把这个食物放进去的时候，它已经有很多的能量在这里。
Yeah. And when he was making this, he found that the solution becomes really black, and he said it's burned the food.
然后他发现这个溶液变黑了，它看起来就像是把这个食物给它烧着了一样。
So he tried to find the balance, and he had some baking soda.
然后他为了达到平衡，他加了一些苏打，就是烤面包用的苏打。
Yeah, to try to add the best mixture. So he makes different try, and you can find different solution. In liquid plasma, you have 3 different documents how to do it like that.
所以你会看到不同的这个解决方案，不同的方法。
Perfect.
Yeah,
So
I
then,
told you. Okay, go ahead.
then you have the fourth method.
哦，现在我们有第4种方法。
The fourth method was from Paul in Togo.
From Berlin to go.
Jackie and Ruthie, it's important here that you tell the Chinese, Ruthie, that they can choose between, they can choose their method.
Yeah， 就是你可以选择你想要的方法。
And absolutely, Tobian. The Paul decided that because here, for example, you have the NaOH, okay? And he found with the citrus, lemon citrus,
用那个柠檬酸
and salt.
或者是盐。
If you make citrus and salt, you get NaOH.
用柠檬酸和盐混合在一起，你得到了这个烧碱。
So he found that only with citrus and salt, you have a natural way to NaOH your food gains.
这是一种天然的方法，用来这个制作食物干丝，就可以获得这个天然的氢氧化钠。
And is a really good add to the knowledge. He don't focus on the lemon or watermelon or the elements. He focus on the composition of the element.
它并不是只是聚焦于某一种这个元素，它是主要是这个就复合，就是它们的混合。
So, for example, if you take a watermelon, you don't look at the watermelon.
比如说你是这个西瓜，它看起来并不像西瓜了。
For him, watermelon, for example, if it's B1, B3, B6, and all the compositions. So he focus on this composition of the food and not on the material state of the. So he don't try to make a watermelon GANs. He try to get the B1, B2, B6, and all the elements of the fruit or the vegetables.
所以你不是说去做一个西瓜干丝，而是你因为西瓜里面它有 B1、B2、B 就是 B6这些所有的维生素，所以你实际上做的是这些东西的一个混合干丝。
Exactly, and then we have the last method. It's when Mr. Keshe said, just take, for example, a chili, mix your chili, put with, for example, CO2 plasma liquid.
Yeah. 那第5种方法呢，就是像凯斯先生说的，比如说你做辣椒干丝，那你只需要把这个辣椒，跟这个二氧化碳的等离子水，然后混合。
And then you mix in a higher speed your solution with a mixer. You try to mix as fast as possible your solution.
然后你就是说用最快的方法来混合。
And it will expand the field of your chili, for example.
那它就会扩散这个辣椒的场，扩大这个场。
So my solution, the 6 I take, it was a mix with that. So I take this method and I just add into this, I just add like Paul showing the Togo, I just put the citrus juice and the salt to get a little bit more NaOH. Okay.
OK，我的方法也是先用一些柠檬酸跟盐混合在一起，以产生氢氧化钠。
And so this is the sixth method and the little story regarding the food GANs.
所以这个就是我们做这个食物干丝。
能问一下那个柠檬酸的，比如说它那个溶液的浓度，还有盐浓度，就第四种方法当中有没有细节？
So I mean the how to say that citrus
极致
浓度 no I mean the concentration I mean the density of the concentration of the citrus and the salt. They want to know
the quantity.
Yeah.
Okay. My point of view, it's like ever said Mr. Keshe, in the world of the creation, there is not a lot of measurement. It's some quite like an environment, and this environment produces something, but it's not something who everything is how you say. You need to let your creation flow. You need to. It's a small quantity of citrus, okay, and a small quantity of lemon juice, but you need to make different try. It's not something like this. You put 10 grams or 22 grams. I don't know exactly.
Okay, so that looks like Chinese cooking, you know.
Yeah, absolutely. When you cook, you can take full recipes and follow everything, but you need to add your touch, your creation, your feeling, your love, your appreciation, and play with this. It's a child game.
OK，所以 Jackie 说其实是没有测量方法，然后我就跟他讲说，这形容有点像那个中国做中国菜。他说，对你虽然有菜谱，但是其实当你在这个做饭的时候，其实是一种你放了你的爱，放了你的所有的情感，然后这些东西都放进去，它是一种能量的流动，然后其实是一种感觉。The art of cooking 。
Yeah, and practice.
Don't play with black cans. Don't play with black cans.
Oh, don't play with black guns. Okay. I just make some guns come out from the skin of the egg, and I use the how to say that? I use the white vinegar, and I crush the skin of the egg into small, very very small particles, and I boil it, and after that I just have the surface water. I mean, I put there for several hours, and I have I just have the clean surface water out, and I put some white vinegar inside it, and put there for 2 days. And later I add some NaCO3. I mean, I don't have NaOH, and I have only that. And I put it there, and I found some white things like milk produced from the clean water, and later I just put it there for several hours, and I found that I have some white, very like scans, yeah, something there. So I think, but some Chinese also teach me to do this with white vinegar. It's very interesting.
Yeah, the vinegar, it's like your citrus, it's like your, but citrus for the NaOH and salt, you have the NaOH formula.
No, I don't add the salt. I don't add any salt. I just add the vinegar, and later I put some NaCO3. I mean, I use that to replace the NaOH.
Yeah.
Yeah, and to mix together.
And one important thing when you choose your method, if you want to play with HCl, NaOH, different chemical elements, I don't recommend this method when you want to eat.
Oh.
When you want to eat your food GANs. I don't like to eat when I add this because you need to take so much time to clean your GANs before. Yeah.
对，他说就是如果你做的食物干湿，你是想要去吃它的话，那我就不建议你们用这个盐酸和这个氢氧化钠溶液，因为这个东西需要太久来清洗很多次你的干丝。所以我刚才跟他分享的就是我用这个鸡蛋皮，然后把它弄得非常的碎，然后就是加水，然后去煮了一阵子之后呢，我就把上面就把它倒出来，然后加了一些白醋进去，然后这样子放了2-3天之后，我就取上面那一层清水，然后取出来之后再加入了这个加入了碳酸钠，就是这个食用碱，然后呢，它们中和了之后就产生了白色的像干丝一样的东西，然后他就说这个这个醋其实也就像是这个柑橘子汁一样，因为他讲的是其实有一部分是指的这个 cereus 是橘子汁应该是。对，然后这个就是我试图用它来做盖干丝，就是这样的一个做法。
But it's really good if you want to make some patch or play with the fields.
所以用这个盐酸跟氢氧化钠的话，他们做的这个干丝，比较适合用来做这个就是干丝贴，或者是你想要去玩整个这个干丝的场。
But it's really good if you want to understand how the body transforms the energy of the food with this process, with the caustic, and then release the energy with the acid solution.
很重要的是，就是你要理解身体是如何，就是用这种方式来产生这个干丝的，就是用这个酸，然后又用碱。
And if you want to eat the food GANs, I give you the tip to make with the citrus, salt, and mix with the mixer, high-speed mixer. And so you don't need to wash your GANs, you can consume directly with no problem.
所以如果你是用这种橘子汁和盐水混合，然后呢，或者是用这种高速旋转的这种方式，那你做出来的你是马上就可以吃的。
How long do you have to let it sit?
With this method?
Yeah.
For example, I consume quite directly. I make it, I mix, I let 5 minutes settle down, and I take the liquid.
就是你这个要做多久？他说这个很快，我几乎就是同时的，我把它混合在一起，然后我放在那里5分钟，我就可以用了。
这种情况可以一直吃，一直有这个原先的味道吗？
Yeah, they ask that the food GANs, if the food GANs can taste or smell with the original smell or taste, because he said when he made some GANs from Chinese medicine, and he found that it don't have any taste.
Did he mix in the mixer the solution with the CO2 plasma liquid?
他说你做的时候，你是用那个二氧化碳等离子水做的吗？
用的烧碱把它化了以后呢，又把它放在二氧化碳的盒子里边做成干丝，做干丝这个过程经过了，最后还没有味道。
你是然后药是放在哪儿啊？你刚刚说把烧碱化了。
烧碱放到药里边，然后这不变成颗粒了吗？变成颗粒以后呢，我又用酸，给它中和了一下烧碱，用的是醋，不是酸，用的是醋。加了醋以后呢，调 pH 值调到7，放到二氧化碳的盒子里边去以后，再去做二氧化碳的干丝，这样做一段时间，是这样出来的。
Oh, so he first he put NaOH into the medicine, and then add it into the CO2 kit. 你是什么时候加的那个酸呀？后面就是做了也就加酸了吗？
他就是用那个烧碱混合了药以后，它已经成颗粒了以后，又加了是醋，用醋去调整 pH。
Oh yeah. So first he put NaOH inside the medicine, and later mix it, and later he put some vinegar and adjust the pH equal to 7, and then he put those into the CO2 kit and to make GANs. And after that, he found the GANs had no any taste.
Yeah, absolutely. If you want to have a good idea, just let's say to him, take a chili, put your CO2 liquid plasma and mix it really fast, and you will see that you will expand the taste of the chili by the 2 or 3 or 4 or 10 with this method.
他就说你就像最简单的方法就是做辣椒，然后把它放到二氧化碳的液态这个干丝水里面，然后用非常快的速度去旋转，然后这样的话这个辣椒会辣好几倍。他是这种方法来做。
It's also, you can tell also, Ruthie, that the steadfast, clear intention between the medicine and food. If you go back and forth, it would lose the fields.
他就说你要明白你的这个意图。他说你如果就是来来回回的这么去做，你可能就失去了这个它的场。
多谢。
Okay, it's interesting.
I brought in someone else to ask a question here. You're at the bottom of the list. At the bottom of the panelists. And also there's a number of questions that were typed into chat too.
Hello?
Yes, hello.
May I ask some question about the microwave unit?
Okay.
No, you're the boss, Ruthie.
Yeah, I just want to say maybe later, is there still any question about, but seems that already go a lot of time and to answer all the questions.
You know, fortunately, Jackie showed up here because I'm not very good at food game.
That's great. Okay, no problem. 好的，您是哪位？请讲。
我是阿基啊。
阿基，您问吧。
好的。I want to ask some questions about the microwave unit. And I made some microwaves, but I can't see any obvious reduction. Actually, electrical power reduction, and I have some very confused about the connection, like the conductor and with the coil. How is which way is the correct way to connect them? And I investigate a lot of information, but I can hardly find any clear answer. Because, for example, the blueprint of the offshore side have not marked the polarity of the conductor. So I don't know if what I have done is right or wrong.
Well, you since you created your own magram, it's specific. You should take a picture and share, because there can be many things to review. For example, what is your distance between the coils?
阿基他是说你最好是有图片可以展示，因为这样子他会比较清楚。然后比如说他问你那个线圈之间的距离是多少？
我能不能分享一下我的那个 camera？ 哦，这样。Can you see?
Yes. Can you lower the camera? What GANs did you? I can't see the GANs. It's only nano-coated?
I coated with GANs and liquid GANs. It's very little.
It's a terrible echo.
You'll have to mute your speakers there at your end or turn your volume of your speakers down when you talk there.
I'm afraid. I think what happened here, dear friend, is that when you dip the coils in the GANs, then if it's too much distillated water in the GANs, then the layer becomes so thin that the nanomaterial has nothing to play with.
你听明白了吗，阿基？
那你翻译吧。
我翻译的不好，他说可能你把那个他看不到干丝，就是说你这个就是铜的这个纳米铜线圈啊，当你放到那个干丝水里面去蘸的时候，他说可能是不是那个干丝水太轻了，然后所以说上面就没沾上什么干丝，所以这个纳米铜线圈就没有办法跟它的那个场像去作用，他是这个意思。
OK。And so I use and one of my questions is that in the previous blueprint of the microwave unit is different from the off-grid one. The off-grid system use different gases on each coils separately, but yes. But the previous microwave unit use a mixture of 3 different GANs.
Yes.
So which way is correct? I can understand the off-grid one, but I don't understand the previous one.
The off-grid system is slightly different, but it doesn't really matter, you see, because the once you have a clear mix with at least zinc, iron, and copper, then it will create a pattern that is largely enough to get the field and the vortex. But in this case, is this a 2 times 3 stacker?
Yes.
And how did you couple? How did you connect them?
You mean the connection between the coils, or between the coil between the conductors?
Between the two magraphs.
2 magraphs. So it's how to describe it? So the first one is basically they are connected parallel, in parallel. And first one on the live line into the gravitational input of the first unit, and the output, and the second one basically is in reverse, in a reverse way.
Very good.
So
what is
maybe it's the collection is the same as the picture that Armin has published on his Facebook.
Yes.
I think it's exactly the same as the picture.
But you see, there is no sign of the GANs, and that's very important. It is the connection between the nanomaterial and the GANs that is going to create the difference, you see?
Yes. So you mean the GANs is too much less? It's too less. I should put them more.
Yeah, it's not enough.
It's not enough. Okay.
Yeah, because you see, you have thousands of layers of nanomaterial, so that makes your magrav ready. But the GANs layer is where you get the pulse from the magrav as much as from the hybrid.
Okay.
The off-grid system.
Okay. 那个自由的心，你要翻译吗？
And also, what did you put on your load side?
Low side.
The load side, yeah.
Load 负载
Low side is a computer.
Because you see,
computer.
only computer load side.
Yes.
no, you have to put more heavier things on the load side. You see, you have to put, for example, one lamp, one refrigerator. That's very important.
所以他说你的负载要放一些比较大一点的，比如说灯啊，或者
I
是
think the load of my computer is bigger than the lamp and the refrigerator. You can see it. It's my power meter.
Yes, but it's very much like the lamp. You see, the usage from the grid side is too conform, too linear. That's why the fridge is much better. You will see, even with such a low level of GANs on your coils, you will see the result once you put something more heavier on your load side.
Okay, I have another unit connected to my refrigerator, but it seems that it doesn't work also. And I use a gauge meter to measure the field. You can see it. This one connected to my computer, it seems much stronger. The magnetic field is much stronger.
Yes.
Then the one I connected to my refrigerator.
Yes, your system looks very good.
But I can't see any obvious reduction.
Can I just add something? Because yesterday was an incredible, the first power generator off grid was released in public, from a public in Turkish. After I let you speak, because I need to go, I just show you this, you know. You can see it's in the public Turkish app from 3 hours and 30 minutes he presents. So you can see the current, this is no current, is off, this, and his system, yeah, it's off, and the system works perfectly with no electricity coming. And this afternoon they will make another live workshop. This is from Turkish. The first off-grid system working from a public. It was beautiful.
Okay, let me translate.
Yeah.
所以 Jackie 这边他是展示了这个昨天的土耳其的公开教学的这个第一个就是离网系统可以工作的，这是土耳其这边他们昨天展示的。
So just it's a great news I want to share with you. The first was shown off grid, and this afternoon they make another presentation.
然后他们今天下午也还会再做另外一个展示，这是一个非常激动人心的消息。That's great.
Yeah, it's wonderful. The first public showing this.
Yeah, great.
We can give a great applause, champagne.
Yeah, so our Chinese should speed up, and we will have our own off-grid system.
Yeah. So thank you so much, guys. I need to go, sorry. And you are in good hand with Torbjörn and Flint and Ruth.
Yeah, thank you so much, Jackie, for supporting us and joining.
Yep, thank you, Jackie. See you later.
See you. Bye-bye.
Bye-bye. Now, it's very important when you have a double MAGRAV system to have a culture using the load side, because it's 70 to 80% less reduction, and if that doesn't happen, then it's something wrong with the system. You see, that's important.
Yes, but how long it takes before the reduction begins?
Well, it should start. You should start to see the reaction at once. You see, yeah. When just for example, when you put the fridge on the load side, then don't take it off again. And then you add a fan or a heating system, and then you add a lamp, and then you will see the reaction straight ahead.
Okay, you mean I should add more loads to the load side?
Yes.
Okay, let me try to translate, because some other people, they don't understand. I try to explain it in shortly. 所以基本上阿基的这个系统呢，这个 Tobin 是说，首先第一个，它的那个干丝的涂层，他觉得做的太薄了，看不到干丝，所以觉得可能是这个就是纳米涂层跟干丝之间还没有反应。第二个呢，就是他讲到它的负载太少了。阿基它有2个系统，一个系统是接到这个电脑上面，另外一个系统接了一个冰箱。然后呢，Tobin 是说。首先你就是把一个冰箱加进去，然后就不要再关掉了，然后呢再加一些风扇，还有就是这些加热的系统或者是灯什么之类的。OK，go ahead.
So the previous microwave unit system needs taming usually needs taming, but the recent video like the off-grid one or the two unit system, this seems like start working very soon, very quick.
Yes.
But why? I don't understand.
Oh, there can be many reasons, you see, because the distance between the coils and the GANs, that the GANs result means very, very much to the whole system. But then the culture, the way you use your load is very important as well. Because you see, you will find out that the more you put on the load, the less you use from the grid.
Wait. 所以3件事情非常重要。第一就是你线圈之间的距离，第二个就是你这个干丝的涂层的厚度，然后第3个就是你的负载。然后就是说，因为你要想节约这个70%，就是你这个负载它越大的话，那么它从这个就是持引力单元所获得的这个能量是越少。
And that is especially for double magrav.
Okay. So the double magrav system doesn't need the taming. Do you mean that?
Sorry?
Do you mean that the double magrav unit system do not need to be tamed?
No. You should see the result at once. After 2-3 minutes, it becomes clear.
Okay, but I'm wondering that if the magrav unit system released by the offshore side, sailing on the offshore side, has the older one is blue color, the new one is in white color. What's the difference? What's the difference of these two kind of unit? Exactly.
请稍等，我翻译一下之前那部分，就是说Tobin 是说，尤其是2个磁引力单元接在一起的这种就是连接方式的话，你应该是在2-3分钟之内马上就可以看到这个截片的效果的，这个是不需要去驯化去等待那个很长时间的。然后刚才这个阿基问的是说他们有2种这个就是正式在官方在卖的有2种系统，最开始是一个蓝色的盒子，现在有贩卖白色的盒子，那这2种有什么区别？
My experience with the double magrav is that I put up to 9,000 watt, and there were hardly any usage of the grid at all.
Okay, so it means it's almost off grid.
Exactly, almost. The kilowatt measurement nearly stopped. It stopped from time to time.
How is exactly is the power of your node? My power meter have a limitation of 2500 limitation. 2500 watt limitation maximum.
Yes, it's the it's the plasma taking over for the whole grid system. That's how it works from the load side.
请让我翻译一下。就是说，Tobin 说，当他把这个负载加到9000瓦的时候，他发现基本上就不消耗电了。他用他这个设备他的这个仪器测不出来了，就几乎等于一个离网的这个概念。
Okay. So may you answer my the previous question? What's the difference between of the blue one and the white one?
Well, it doesn't really matter. You see, you can put gravity to gravity and magnetic to magnetic, and you have the same result. But it seems that if you cross them, it lasts longer. The effect lasts longer.
I think, Tobin, you didn't understand his question. He means that there's two kinds of macro system unsetting from the Keshe Foundation. Yeah, and one is blue and one is white. He asked, is there any difference between these two kinds of macro system?
Well,
the only difference is the blue ones has 220-volt plugs coming out of it. The white ones have the 110 for the USA. And is China 110? Are you guys at 110 volts over there?
No, we have 220 volts.
220. So the blue one would be more appropriate if you're going to get one. But then you'd have to change the plug because it has a European style plug on it. You have a Chinese have a different plug.
And the white one is produced in US or both produced in Italy?
No, Italy does the blue, US does the white.
Okay, so right now, no matter white or blue, are both produced from Italy factory, right?
No, both.
Both?
Italy does the blue one with the 220 plugs. The white one is the USA with the 110 volt plugs.
OK，所以他是说那个蓝色的这个是意大利生产的，然后是220伏的，白的可能是美国生产的，是110伏的。那我们是要买那个220伏的，但是呢，要换那个插头，因为我们这边是欧洲的插头。
Internally, they're the same.
内部是一样的。
So how many capacitors have you used in your microwave unit?
I use either. I made many, but what they have in common is that I use 4 capacitors on each side, or 3 capacitors on each side. So 6 together, or 6 or 8 capacitors together.
So do you mean that you connect 3 or 4 capacitors between the live and the neutral line, and 3 or 4 one between your gravitational and magnetic input and output between the coils? Do you mean that?
Exactly.
So may I ask the exact the direction of your capacitor? How you connect it?
Yes. You see the tail that represent the gravity line? I call them the tails because it's only one needle, right?
The tails means that the magnetic output. Do you mean that?
Yes. So I put all the tails together, even if it's 6 or 8 coils. Capacitors. Yeah, I'm gathering all the tails together. So the blue line stays in the background. That's where the capacitors comes together.
I I haven't understand yet. Do you mean that you connect all the capacitors tails together and connect them to where?
It's the once you have the input and output in the system, then you put the blue one by one on its tail, 4 times 2 or 3 times 2, and then you have clockwise and anti-clockwise on the magnetic line, the magnetic energy, and then that's the plus side to the MAGRAV system.
You mean the tails connect to the plus side of the MAGRAV system? Do you mean that?
Yes, the neutral part.
The neutral one.
Yeah, and the positive, which in Europe it's brown.
Oh, okay. The plus side of the coils. Do you mean that the magnetic output? The output side, that means the output of the coils is the magnetic one. Do you mean that connect the tails of the capacitor to the magnetic output?
Yes, you see the tails, what they have in common is the gravity field. So you only change the clockwise and anti-clockwise on the magnetics on the copper spin. You see that makes the difference between the two capacitors on left side and right side of the input and output.
Oh, okay. Could you please clarify that the counterclockwise one is usually in the magnetical, and the clockwise one is used in the gravitational?
Yes, I have a. I should. What I can do, Ruthie, is to take a photography of the connections, and then for the next program, you can use that photography and show for all the Chinese.
Oh, okay, I try to make one.
Or you could just do live video.
Yes.
Oh, okay. Okay. Next time I will draw a picture so everyone can see it.
Yes.
Fangji needs to share the application that's showing the picture because the screen is gray right now.
It's hard to explain and very easy to show because when you're spinning capacitors, then the only difference between them is clockwise and anti-clockwise. So you realize that what's the input and what fits with the input and what fits with the output to the whole to the 3 coils. When you connect them together, you put the magnetic capacitors to the gravity field and the gravity field to the magnetic capacitors.
I need some time to understand it. I need to took more time. Yeah.
Hey, Ruthie, can you tell Fangji to share the application of the picture that's showing the picture, because we see a gray screen.
Because what people in general do are just making capacitors, you see, and they don't create the difference between the gravity and the magnetic field. It's just capacitors. That works as well, but that's none of my experience. And I've even seen that people are connecting the the capacitors together, series couple them, and that doesn't work. You have to connect them one after the other.
Oh, may I ask one more question?
Of course.
How do you make your capacitors? I mean that my GaNs are almost wet when I make my capacitors. So when I have done, I put all the capacitors into my oven to heat it to make it dry. Is that correct? Or
don't put them in the oven. Because when you put them in the oven, you get a very strange nano cover, and it's going to interfere with the GaNs as well. You have to use the vacuum, the normal air around to and be patient and let them dry.
May I use the dryer to blow them?
Of course.
To fasten this.
Yeah, but don't take the dryer very close, because once you heat up the copper, then it also interfere with the nanomaterial and the GaNs.
Ruthie, you there?
Did we lose the bus?
Oh, yeah, I think we did.
房子可以问问题啊。
Okay.
我有个问题哦。可以直接提问吗？
Can you, Feng, you there, Feng?
Yes, I'm here.
Can you tell Fengji to reshare his screen or reshare the application that's showing the picture, like the Windows?
房子啊，他叫你再重新共享你的荧幕。
哦，这个看不见了是吧？
是啊，看不见。
行，稍等一下啊。
Just wait.
Yeah, he has to share the direct application that is showing the picture.
Yeah, I think he's
那能
doing.
看见吗
No, we still can't see. 还是看不见。
那这样，稍等，我停止一下，再。
You got to stop for a while, and then redo it. 啊，可以。
可以是吧
Can you see?
When he double clicks a picture, the picture is opened up in Windows Photo Viewer. That photo viewer has to be shown, not the folder of pictures.
他说不是把那个资料夹打开，而是把那个照片你要
我明白了，
照片打开来。
明白了。我直接共享桌面上的。OK， 这下行了吧？
Yes.
Okay, yes, now that works, and now he can go back and forth in there.
是这样的，我有几个问题想问一下。刚才阿基问的就是说做能量单元的时候，有特别重要的一个就是你们说的两组线圈之间的距离很关键。我想问一下，这个两组线圈的距离，指的是你那种平层放的那种线圈，它两组之间的距离到底保持在多少距离比较合适？
He asked about the question just now posted by the person about seismograph coils, and Jubon answered the distance doesn't make a difference. So he wanted to know what's the appropriate distance.
Okay. The
distance are only important when it comes to maggrav systems, 3-stacker, 5-stacker, and 6-stacker, and so on. That's when the difference matters, and the difference, the distance between them should be not further away than 1.5 centimeters, from 1 to 1.5 centimeters.
OK， 他说那个距离不要超过1到1.5 centimeter cm， 但是当你做那个 stack 就是3个、5个情况之下才是要注意的。
好的。那还有一个问题呢，就是这种纯直摆放的线圈的话，它们之间的距离，应该保持在多少？
再说一遍，听不清楚。
就是这种纯直摆放的十字线圈，它们之间的距离应该保持在多少？
是传统的这个线圈吗？
不是，就是后来凯史先生教学的时候，不是有一种里面的线圈和外面的线圈交叉摆放，十字垂直摆放的这种线圈，它们的距离应该又要考虑多少
？Hans has another question. He wanted to know about this graph unit. One is vertical, one is horizontal. And what about the distance in this sector?
In this system, when you have the inner core, when you have an inner coil in 90 degrees, then sorry. Then it doesn't matter because the interference with the vacuum is working differently.
这个就不重要了，因为它的影响跟空气的关系不重要的。
So the one of the difference is for health purposes and star formations.
所以它的其中一个的用途就是在那个健康的那个 health unit 和 star stack 那边应用的。
也就是说，这种垂直摆放的时候，这个距离是没有要求的，是吧？
Yes, again, then the distance between the coils doesn't matter. Is that correct?
It doesn't matter. It's not that you're completely free. there is rules, but the rules has to do with health and star formation, referring to what Ruthie calls UFO. And then there's a different.
完全没有影响，是要看你在哪个用途之下。
And also, you can say that the usage of GANs is different also when you use this kind of structure.
在这种结构之下，用的干丝也是很关键的。
So we have many ways to use the ganses for when the coils are putting this way.
所以我们有很多方法用干丝在这种应用之下。
As a good example, you can put the sink on the top.
你可以把芯放在上面。
Only sink gans.
使用芯的干丝。
For the outer and inner core.
You mean both outer and inner?
Yes.
放到里面和外面的线圈。
And then you can use copper, outer, inner in the third level.
Third level, you mean the lowest?
And iron on the lower coil.
Sorry, Tibon, can you repeat?
On the lowest coil, you can use iron gans and.
在最底的那个线圈可以用铁的干丝。
So you have zinc, copper, and iron.
就是 the second one you use copper gangs.
Sorry.
我们现在这个纳米这个干丝涂层的线圈是用这样的方法，就是
下面 using in our system using the gangs in right now. 你听得见
？Sorry.
这下面的一层呢是我们用的也是一种混合干丝，3层的混合干丝比例都不同，根据那个阿丽在Facebook 上面有一个他提到的干丝的比例的问题，中间呢相对的干丝的强度要比较强， 然后上面和下面的相对的比较弱，这样的。
The gangs we are using now is of a mixed type, with the least strength at the bottom and the strongest gangs at the top. It was shown in Ali's Facebook, so they follow it.
Exactly. We have many variations. It depends, because you see in this structure, what you have is like a rocket formation, and I've never seen it before. It should be a tree, because the positioning is very important when the coils are used this way.
因为钢丝的应用也有很多不同的情况，而这个结构在对我来说也是从来没有看过的。
So you can tell as an example that if you use the three stackers below, then you have to lift off the center.
Sorry, the three stackers below, what?
Yes, if he's using the three stackers below, then he have to lift the fourth reactor higher up than the star formation triangle.
如果下面是3个的话，那么第4个呢，就要把它举得高一点。
Okay, he's got live video here now.
那个，我想问一下，就是刚才提到的2个能量单元互相连接，然后能立刻省电70%的，这种连接方法是什么样的一个连接方法？
你再说一遍，有一点断了，我听不清楚。
就是刚刚那个他们有提到说2个能量单元连接起来之后，能立刻省电70%。我想知道这2个能量单元之间它们怎么连接，有什么规律？
He's asking about the 2 McGrath coils just now. How do you connect the 2 McGrath coils to achieve that 70% of reduction?
Oh, it's the same thing. You put the general output of gravity and magnetic field opposite from one to another.
你把它的 McGrath 就是磁和引的端，把它相对连接。
Yeah, the gravity to the magnetic field. Sorry.
You connect it.
没清楚，能再重复一下吗？
什么？
刚刚你说的那个发音那个没听清楚，再那个能重复一下吗？
Can you repeat what you said?
Yes, when you have a star formation, you have a triangular shape on the floor, or
有一个星体的时候呢，你就有一个三角形在地板上。
And you start to connect them from the gravity to the magnetic field.
然后呢，你就把细的那个就连接到引的那个。
And the magnetic field to the gravity.
然后把它的另外一个呢，就是磁的连接到引的那个。
And then you will end up from the triangular shape with only 2 output, magnetic and gravity.
这样的连接的话，最后你就只有2个端，一个就是磁的，一个就是引的。
And then you put those to the same gravity to magnetic and magnetic to gravity on the upper level, which should be 10 to 15 centimeters above the star formation, the triangle star formation.
然后也是把同样的2个端呢连接到上面那一组，它们最少呢要有10到15个 centimeter 的距离的。
Also, Young, we can take the example of 5 plus 10.
比如说5个百分比啊。
The latest star formation from Arizona.
从 Arizona 的那个例子来讲。
Then it's like it's connected like a spiral.
它们的连接就好像一个螺旋形。
And as a result, you only got 2 circles.
这样子的话呢，就只有2个圆圈。
So the five magravs represent the inner core.
Sorry, what do you say?
So the 5.
画个图呢，简单的。
啊？什么
The 5.
Oh, he's asking you to, if you have a diagram.
Well, actually, Ruthie showed the picture this morning, where it's easy to understand that the 5 magravs represent the inner coil, and the 10 magravs around represent the outer core.
他说，Ruthie 今天分享了一个图，外面有10个圈啊，线圈啊，然后里面有5个这样子的。
From Arizona.
从就是美国亚利桑那那边，他分享了这个图的。
There it is. And you see the way it's connected here. You can see that there is only one line from the inner core.
从这里可以看到它的连接呢，它里面就是只有一个连接的方法，一条线。
It's a in and output to the inner core and outer core.
它的里面的那个 core 呢，是连接到外。Is it all the inner cores are connected, or inner core of one connected to the magnetical to the other?
Yes. So that's the that represent the superconductor inner core or
okay,
inner
core and then macrograph, just like that.
Okay? Exactly.
他说就是这个的 unit 呢，这个单元呢，把它的 inner core 它的 G 那个引力呢，去连接到另外一个它的磁力，那么另外一个的那个引力呢，也连接到另外一个的磁力，就是相反的。
This only has to do with the positioning.
What positioning?
The positioning is the way you put the magravs, so that when you use a fan, you can see the field, see and feel the fields.
就是当你放置的时候，这样连接，而你用一个风扇的时候，可以看到那个磁场。
And Young, you must translate as well something very important.
他说还有一点重要的。
When you connect one magrav, the gravity and the magnetic field with its opposites.
当你把2个单元连接的时候，这个进口连接到另外一个的出口的时候
，you increase you increase the fields.
你增加了它们的场。
That's why it's so many magravs.
所以呢，有那么多的单元连接在一起。
And from Arizona, they show that 4 magravs leads to 0 usage from the grid system.
所以当4个，他们Arizona那边把4个这个单元连接在一起呢，就产生了 完全没有用到传统的电的系统。
But now this morning, Jackie said that the Turkish has found 100% off-grid, so it's champagne time.
但是刚才 Jackie 说土耳其的那边完全达到了100%的这个情况，是值得祝贺的。
So they're going to have a presentation. Flint, did you read? Is it a presentation today?
Tomorrow.
Tomorrow.
Oh wait, no, this afternoon. I don't know what time. I'm assuming 2 p.m. CEST on the Turkish channel, the public Turkish channel.
Okay.
Probably.
I'm assuming that. Yeah.
他们也不太清楚，因为有可能会有一个公开的示范，就是在土耳其那边的公开的教学 （public teaching） is it？ So 可能会有，但是他们也。
I hope we're all invited.
还有问题吗 ？Is there any questions? Any more?
There are quite a few questions in chat here that people have written, one in the Q&A, and there's another dozen or so in the PowerPoint presentation that I have from Ruthie. So we have lots of questions that aren't answered yet. So Ruthie, what do you want to do?
Yes, thank you for translation, and I'm back. What I want to do, I want to close the teaching.
Let's go through the questions, Ruthie, as fast as possible.
Okay, so let's try to answer some faster questions. So one question is, what's the distance between the cores for the Magra system?
In the Magra?
Yes.
It's maximum 1.5 centimeters between them.
Maximum 1.5 1.5
centimeters.
Centimeter.
Yeah.
Maximum,
yeah. It should
you
be
mean
1 centimeter.
You mean the inner and the outer, right? Not a stack.
Oh, you don't mean the distance between the coils?
Ah, okay. Because that's also the distance from coils from different stacker. Okay. 他说这个就是线圈之间的距离最大是1.5个厘米。But how about the stackers? The distance of different stackers?
Oh, well, it seems that in Arizona on this star formation, it's approximately 1 meter between them.
1 meter between them. Oh, you mean the stacker to stacker is 1米？他是说最1米的间距就是。
Like, you mean 1 meter in the picture like you're shown there?
Yeah.
No, I mean is the inside the Magra system, the between the different stacker. What's the difference from the top, middle, and the bottom? Yeah.
Do you understand, Tuver? She's asking the distance separation between each of the 3 levels.
Yeah.
Yeah, the 3
which is
like
40 centimeters, right, or something like that? Not 40 centimeters, 40 millimeters, or 4 centimeters, right?
No, between the 3.
You have a top coil, middle coil, bottom coil. Separation distance.
Oh, that depends. You see, that depends on the thickness of your. If you.
I know, but generally you want the ping pong balls stacking on top of each other, which ends up being about what, 4 centimeters 5 centimeters? What's the distance there between your levels on yours?
I'm not sure I understand. Oh, you mean if you put the 3 ping pong balls together?
You have a top coil, middle coil, bottom coil. What is the difference? What is the centimeters between top coil, middle coil?
Oh, like I said, maximum 1.5 centimeter at the maximum.
The coil is sitting on a shelf.
Yeah.
What's the difference? What's the space between the shelf?
Maximum 1.5 centimeters.
Still doesn't make sense because you have a 36 millimeter ping pong ball.
Yes, that means that if you're using ping pong balls as the GANs grave, then you have to get them as close as possible as a compromise.
Correct. That is correct. So the balls are maximum of 1.5 centimeters apart. The coils are how far? They're sitting on the center of each ball, so that puts it at like 40 millimeters, or what's the space on each shelf?
Well, what I have done is to use very often a compromise. I'm forced to the diameter to put them as close as possible, and
yes.
And it's not possible if you use ping pong balls. So you get at the max 2 centimeters between them, and that's a compromise. So what I have done is to play with the center and put the 2 outer ping pong balls slightly out of the center for the coils to get as close as possible.
So vertical distance between top coil, middle coil.
It's depending from one maggrav to another. Next question.
You make me crazy.
I don't know. I can't get a straight answer out of him either.
Well, the straight answer is
like me to guess. And
Ruthie, what people can do, what I did, was to increase the diameter on the copper so that the connection is perfect in distance. So 1.5 at the max. I'm actually having 3 coils that are 1 centimeter between them, but that's when you increase the diameter on the copper.
I think, Tibon, they're asking for the distance between the 2 maggrav setups.
Oh. Well,
I think it would be better if the vertical stacker can be as close as possible. But just now you mentioned one of the 3 main points is that the distance does matter. So they're asking you what is the appropriate separation distance.
When I made a double maggrav, and
Lord.
there are 8 centimeters between them, the 2 magravs, in one box.
I don't know if that answers. You guys do the best you can there.
Okay. I remember for the German foundation, Farhad, they made 45 centimeters
Oh, no.
for the distance.
Yeah, 4 to 5, or say, yeah, 4 centimeters is what I was going to say.
Oh, yeah, 4 or 5, yes.
Yeah.
Yeah， 就是说那个好了，那我们都知道了，就是如果是线圈与线圈之间是在同一层的大线圈跟小线圈之间的这个距离呢，他说不超过1.5厘米，那要尽可能的近离这个乒乓球也尽可能的近比较好。然后呢，就是每一层之间的这个距离呢，就是4到5厘米。 就是这德国那个我记得是45毫米哈，然后他讲说如果是要把2个这个线圈并排的坐在一个盒子里面还是怎样，就是2个坐在一起，然后这2个 magra 之间是8厘米 ，no， it's 8 2 magra is 8 centimeter.
Well, it's a question of connection. Well, once you connect the magnetic to the gravity and the gravity to the magnetic, it doesn't really matter the distance.
OK， 就是如果你是连接起来，就是那个磁力连到引力，连到磁力的话，它说这个距离没有什么太大的关系。OK， so this question we closed. And let's say what's other questions? Okay. Is the energy well attenuated after the GaNs water placed for a period of time?
Sorry, Flint, can you help me with the question?
Yeah, I mean the energy of the GaNs water. It became weaker after the GaNs water placed for a period of time.
No, it stays the same for at least 2,000 years.
Yeah, but maybe it will interfere with the environment, right?
If there's GaNs on the bottom,
no,
and there's water on the top, that's where that will last.
I think the question is only GaNs water.
Okay, yeah, only GaNs water. Yes. My opinion is that it will hold its charge for I don't know for how long, but I think depending also upon the environment that it's in, it will. What?
Mr. Keshe says 2,000 years, laughing.
Yeah, that's for GaNs. But if you already made the GaNs water and you place the GaNs water in somewhere and is the energy will decays after placed for a long time.
Never.
Never?
No.
But what I mean is the GaNs water should have interferes with the environment. So
yes, but
yeah.
Let's say that you have a very bad environment.
Yeah.
Then it's a question of time before the GaNs water wins.
Yeah.
The GaNs water will never lose.
Okay.
Even if there's no GaNs in it. Just the liquid plasma by itself.
Yeah.
Yeah.
Okay.
You see the field of the liquid plasma is even stronger than the GaNs.
OK， 他是说这个干湿水就是液态等离子体的话，它放置之后，它的能量不会衰减。他就是说这个它甚至就是说即使只有干湿水在那边，因为他说干湿水的能量可能比干湿的能量还会强。OK。
The reason for this, Ruthie, is because the air and the warm molecules are working side by side.
这是因为在空气中的话，这个空气中的分子是一个挨着一个的这种方式传递的。
Next question.
Okay. So if we're boring the GaNs water, I mean heating it, is that energy will increase 10 times? I don't know who write this, who asked this. Maybe they heard some from the teachings. Yeah, and if we retold the GaNs water, and the energy will enhance 100 times. Is that true?
I haven't seen those calculations, Ruthie.
Yeah, but if it is true that when we're boring, we're heating the GaNs water, the energy will increase, and when we rotate it, and the energy will increase. Is that true?
Rotation, yes, but boiling, I don't think so.
Okay. Okay. So this is a kind of energy increasing or the field increasing. I'm a little bit confused with the question.
Well, the question are answering itself by logic. You know, when you transform the water molecules to evaporation, then it changes the environment. But if it's giving 100 times the effect, I've never heard about that before.
OK， 就是说他没有听说过这种量级的，说什么10倍或者增强100倍的这个，就是干湿水煮沸以后增强10倍，旋转后增强100倍的这个说法。但是就是说，旋转它肯定是会增强这个能量，然后因为它加强了这个就是分子的振动。OK。
Well,
Keshe also said something about this. But when you're in a liquid state, the energy is lower. So when you turn it into gas state, the field will be much more expanded. So you get a stronger field.
Yes, that's the gas state.
And, yeah, when you put it in, you say always put it in a blender if you want to increase the energy. But whether it's 100 times or 10 times, I think it's only an analogy. It's not exactly that figure.
No.
Yeah. Any type of movement will energize the GANs. Because you're bumping each GANs, each liquid plasma particle is its own sun energy. And when you start bumping each one of those into each other, they react and give off more energy. So whether you're manually shaking it in a bottle or in a blender or using some sort of vaporizer machine to turn it into fields, it's going to amplify it.
Yeah， 就是说，当你让干丝运动起来的时候，它这个能力是会增强的。即使说你这样子快速的倒这个水，或者用什么东西把它去旋转起来。
And the next question is how to make water GANs, right?
Yeah.
It's simple. You have a GANs in a jar. You fill it up with distillated water. You wait till the GANs falls down to the bottom of the container. The rest of the clear water molecules will be liquid plasma or water GANs.
But you mean which kind of GANs there? I don't understand.
All the GANses, Ruthie, all of them.
So water GANs is come out from any kinds of GANs?
Yes, you see what is happening when you stir the GANs in the distillated water.
Yeah.
Then when the GANs falls, the water molecules are full of new energy. That's why we're using distillated water.
Yeah.
So it's distillated so that it can be loaded from the GANs at the maximum.
Mm-hmm.
The water molecules.
Yeah.
That's where the power comes from, the GANs. So once the GANs are falling down, it takes care of all the water molecules, communication. And once the GANs is on the bottom of the tank, then that's GANs water.
Yeah, but they want the water GANs, not GANs water.
Oh, that's the same thing.
Wow.
Water GANs and GANs water and liquid plasma is the same thing.
Oh, really? We think that there's a special things which is water. The GANs are made from water.
Yeah, I think the question comes from, you know, you have like an example like apple juice or orange juice is a liquid, but you can still make a GANs of that. And I guess the question may be, can you make water GANs?
Yeah.
Instead of orange juice GANs or apple juice GANs.
Yeah.
Does that make sense, Torbjörn?
Well, I've only made ganses of
Because you can make seawater GANs. Maybe that's what they're asking, or is it seawater GANs?
Yeah, they just say the water GANs. I don't know. They didn't mention the seawater GANs.
Yeah.
But yeah.
Yes, we Monique have made seawater GANs. Is that what you mean, Ruthie? Seawater GANs?
I think so, because if there's no opportunity to make more GANs of water.
No, I don't think so. No.
Okay, so that's seawater GANs. Okay.
Yeah. Okay, so seawater GANs. How do you make that?
Monique is she just showed me a jar here of seawater GANs, so she can tell how she made it.
Okay. Is she there?
Yes, she's 1 meter away.
Okay. Wow, that's great. I'd love to hear from her.
You can explain.
Hello, everybody. Good morning, good night, good evening.
Yes, so nice to hear from you, hear your voice.
I made some seawater GANs here in the north of Europe. We have very good clear seawater.
Yeah.
You want to translate?
Monica 说她用这个北欧的非常干净的这个海水做了一些海水干丝。
So I took the seawater.
我把这个海水拿出来。
I've put it in. This is the Jackie method.
这是用的 Jackie 的方法。
I added up some lemon juice, freshly squeezed lemon juice.
我用了一些鲜榨的柠檬汁儿。
And I took some what we call natron or sodium bicarbonate.
What is that?
Sodium bicarbonate.
Baking soda.
OK， 就是那个就是小苏打，然后加了一些小苏打。
Okay, and I mixed it up. So half lemon juice, a teaspoon of baking soda.
然后用了一茶勺的这个小苏打。
Half a liter. And half 260. You know the jars of the jars of a jam, a general one, which is like 300 grams of jam jar. So half of it was seawater.
So how many milliliters? 100 milliliters?
If you have a jar like this, okay?
OK， 就是有这样的一个罐子。
You'll have to stop. You'll have to stop share to see it.
Okay, can you see it?
Yes, we can see.
Hold on.
Oh, I stopped the sharing. Okay.
Yeah, there we go.
I see. Okay. Yeah.
You're muted now.
Then half of it is zinc water.
有一半是这个就是二氧化碳干丝水 ，zinc water means CO2 water. Yes.
And then and this is seawater.
上面的一半是海水。
And then I added up the soda water and the lemon juice, and I with the how do you call that? Oh God, the rotary kitchen utensil. Mixer. Hand mixer. Which I put inside of it, and I held it for at least 10 minutes in it, with variation in speed.
Okay, so you stir it, right? Stir it. I mean,
the kitchen, you know, mixer.
OK， 就是搅拌器。他用这个搅拌器，然后呢，把这个柠檬水跟那个柠檬水跟盐水。So I forgot how many lemon juice and salt water you put.
Half a lemon juice, half of it, half of a lemon.
Yeah, 有500毫升的柠檬汁，that's half a liter of lemon juice and sea water.
No. You take a lemon, you cut it in two, and you squeeze half of one.
OK， 它只是用了半个柠檬，然后就榨成汁，然后放进去。OK，
Okay, so if you see the GANs that I made in July. So you see it's cloudy.
OK， 你看到这个像云一样的这个干丝，这是我7月份做的。So how many soda water you have added?
It's baking soda, natural.
Yeah, baking soda. How much you put it?
A teaspoon.
OK， 就是一茶勺。OK， 1勺这个。然后就是把它搅拌了10分钟。So you stir it, mix it, and just for 10 minutes.
Yes, 10 minutes.
把它用搅拌器。
And what I do, I went up and down in the bocal, moving the speed of the rotation. I have one of those hand mixer that I can change the speed.
OK.
So I was. Il faut qu'elle parle en chinois aussi.
OK， 所以它就是用这个搅拌器，然后上下，然后改变速度，然后搅拌10分钟。Yeah, that's great.
Stop sharing.
Thank you so much. Okay, let's go ahead with the questions. Hope we can.
I tell the Chinese people that they're asking very particular questions. So it's very hard to give concise answers.
Yes.
This is what she was meaning by the hand mixer.
Yeah. Yeah. 就是搅拌器，这个搅拌器。Yeah, we hope to get more details exactly how to do, because that's really help when people are making something and they have all kinds of questions come out from that. Yeah.
Very good. Monique have 70 ganses now, so they're all food ganses, so it's really interesting collection.
Yeah, I think so. I start to make food gans now and try to make some with Chinese medicine or something like that. Yeah. So I think the 5 question we can jump out. I just already tried that in that way, and I think we also try to can use with the lemon juice or the orange juice or something like that.
Ruthie, Chinese medicine. My mother is got problem with arthrosis. You can translate.
您的母亲得了一个sorry, I don't know that. Could you type it?
Arthrosis.
Yeah. I think I'm really not good at.
What was that, Feng?
它是关节炎。
关节炎. Okay, go ahead. Yeah.
And a very good thing, medicine for it is shark fin. Shark fin, it's good for cartilage. Shark fin. Okay.
他说的是鱼刺吗 ？Shark fin.
对啊，鲨鱼那个鱼刺。
鱼刺yeah.
I can show you. Yesterday I made.
Yeah.
I made cans of that.
哦，所以他做的鱼刺干丝。
Because the Swiss pharmaceutical have created capsule of it.
OK， 他说是什么？是这个苏伊士的这个制药业用这个东西来做成这个胶囊。哇哦！
So I used 3 capsules of this shark fin from the pharmaceutical.
Yeah.
The powder, you know, I opened the capsule and
yeah. 哦，他用了3个胶囊的这个药。You also put the
as usual, I take the CO2. I open the 3 capsule in it.
Yeah.
The powder.
Yeah.
Lemon juice and baking soda.
OK， 所以一样的，他用二氧化碳干丝水，然后用他买的这种鱼刺的这个胶囊，用了3个，然后放进去，然后用了一些柠檬汁，然后还有这个就是这个小苏打的这个水，小苏打。
I made in July some iodine GANs.
OK， you made in July some iodine.
I'm not going to show you because I made in July of iodine.
Oh, that's great. A lot of people want to know how to make iodine GANs. Some people made from some plants. Yeah.
And then this is the one I made yesterday. Iodine. I went to the Edgar Keshe Foundation. They on the net website they have iodine.
The Edgar Keshe Institute.
Oh,
because they sell pure iodine, you see.
OK， 他是说到一个什么样的这个机构去买的纯碘，他们卖这种纯碘，他买了那个纯碘来做的这个碘的干丝。
It's not expensive.
也不贵。Edgar Keshe，Edgar Keshe， 这是一个机构的名字。
他就是那个预言很多那个人啊，美国以前有一个人
凯西是不是？你说那个凯西的预言是？
对，就是。
Thank you.
OK, thank you so much. 他就说这个凯西的这个机构啊，他们在卖这种碘啊，就是他现在展示的这个碘，然后他用这个碘来做这个碘干丝。
Yes, that's the one.
Okay.
That's the one I got.
So also you use lemon juice?
Yes. I poured the 2/3. I poured 2/3 of this little jar. You show the 2/3. I didn't pour the whole jar. Okay. And again, half a lemon juice. You saw the
CO2.
The CO2 and the soda, baking soda.
Yeah.
And again,
Okay.
And you see that's how it is in the beginning. That's the one I made yesterday.
Okay.
So and then it was like that, and now this is the one from July. It's become completely transparent now.
Wow, that's beautiful.
At the bottom, but it's the same thing, same process.
So it takes time, huh?
It takes time. This is a batch of Chinese garlic. You know the fresh small garlic.
Let her translate. Let her translate.
Yeah, let me translate. 这他就说，他也是一样，用半个柠檬，然后二氧化碳干丝水，然后这个就是这个小苏打水，然后加进去，然后他只放了2/3的那个碘，然后就进去搅和。Yeah， 然后他说这个颜色不一样，他之前展示的是昨天刚做的，看到还有很多东西在里面。那他7月份做的那个呢，就已经是纯白透明的了。那他现在手上拿的这个呢，是这个大蒜做的这个蒜的干丝。 Okay, I see.
So in the case of garlic, you have they're small garlic like this. So I peeled it, but I'd washed it. So I cut off some of the peel of the skin, harder skin.
Yeah.
I completely cut down, and I did with the flat of the knife like this to flatten.
Yes. 他就说用这个大蒜把这个表面的硬皮去掉，然后用这种压蒜器把它压碎，然后压扁。Yeah.
And then I cut really, really, really thin. Same procedure: CO2, half a lemon juice, baking soda, a teaspoon, and the mixer.
也是一样的，用二氧化碳干丝水，然后半个柠檬榨成汁，然后就是小苏打1勺小苏打，然后用这个混合器，然后把它混合。
So I've always used Jackie's method. Some of my ganses I haven't. It depends on what I use. You can translate.
就是我总是用这个 Jackie 的方法，那么这取决于你要怎么去用它。
If there's a lot of flesh in the food that I'm making, like salads, there's a lot of fibers or ginger. There's a lot of texture.
Yeah. 就是像你做沙拉一样，你放很多的这种姜啊，或者其他的这些调料在里面。
After depending, I keep on checking, I go like this and I look the consistency.
Okay, 然后
like for instance, this is ginger, this Chinese ginger I did in July. I haven't filtered it yet.
Okay, 这是我7月份做的。
This I will filter.
过滤，然后我后面会去过滤它。Okay. It's look nice. I also want to do something, try something.
And then once it's getting a bit more disintegrated, so to speak, I open all the time because certain I can, and I check and I make verifications, so there is no beginning of mold on the top of it.
Okay, 它就是经常会摇晃，然后去检查看它会不会发霉这样。
So if there is mold on the top of it, I just lift it off.
Yeah, 如果发霉了，就把那表层的发霉的东西拿走。
And I will add up. I just transfer in a fresh container.
Yeah, 然后我就放到一个更干净的这个容器里面。
And I add up some zinc CO2, just a tiny more.
然后又再加一点这个 CO2 干丝水。
And I for 10 minutes again.
再搅拌10分钟。Yeah.
要不要洗去盐分？
They ask, do you need to wash for the salt? But I think you don't add any salt in it.
No, because you understand. See, if you start with the CO2 zinc as the first solution, you already have in GAN state the metal, the sea salt from the CO2 making.
也就是当你在做这个CO2 干丝的时候，你已经有这些所有的元素。Yeah.
So that's a way to avoid the rinsing. You save when you rinse the salt water out of your food stuff, you have to waste so much distilled water.
对，就是所以这种，如果你用盐这种方式的话，你就会浪费很多的这个水，就是这个纯净水来清洗它。 所以so use this way, don't need to wash, right?
It's the poor person way to do it.
Yeah, I like that. 所以他是说这是一个很好的这种方法，这样去做。
But you must know that you really have a good CO2 liquid plasma, which I have with Torbjörn.
Okay, so that's why you work very well. 所以他说你必须要保证你有非常好质量的这个 CO2 的这个液态氮离子水。
So in Morocco, they have an oil called argan oil from a nut.
Okay, 这是一种什么样的油呢？从这个干果里面出来的。
Argan, you see?
Argan, 就是
yes.
从一种干果。
So, and here you can see all the crystal on the top.
Wow, it's like gold.
Yes, and this is all the in that case, the GANs didn't go at the bottom, it went at the top.
Yeah, 就是这个情况下，这个干丝它是从刚开始是在底下，后来又到了上面去。
Because it's an oil, I guess.
因为它是一种油。
But you have a lot of different case of figure, like I made cat food GANs.
Are you there, Ruthie?
Yes, I'm back. Yeah, okay. I just mute my phone.
So what is that's cat food GANs, and you see cat food, and you see half of the GANs is on the top and half is on the bottom.
Okay. Cat food 是猫粮吗？我听起来有点怪。他说这个做出来一半在上面，一半在下面。
Talk about UFOs.
Okay, so now you can change subject of conversation, and if you need to get back to me, I'm there.
Okay, thank you. That's great to show us. 阿基说是热梨。Okay.
Weren't we supposed to talk about UFOs principles, Ruthie?
What? Pardon?
Well, you told in the beginning of the program that we should talk about the UFO principles.
No, I think that's the next class.
Yes.
Yes, of course. And yeah. 谢谢阿基，他说是牛油果，那个弹簧说是牛油果，牛油果你说的是那个就是浮在面上的那个吗？那个弹簧。
Do you think is there some more questions, Ruthie, that's important to answer?
OK, 对，他说yeah, 他说那个就是之前Monica 展示的那个是牛油果的那个油。I think we can have the last one. I think for the we go back please go back. Yeah. Okay. I think a simple question is that is there any difference to use different kind of salt to make GANs? The sea salt or the salt we eat or the Himalaya salt? Is that?
I really believe that it's you the Chinese, you will have very easy possibility to get Himalayan salt. You can get big rocks and grate it yourself. That's, I think, is the best salt if you don't have access to seawater.
他说就是觉得我们中国应该很容易去买到那个喜马拉雅盐。他说那个是最好的盐，如果我们没有办法获得海盐的话。But somebody said that if we use the sea salt and because the sea salt include a lot of elements there, maybe they will impact the pure of the CO2 gas.
Absolutely.
It's very important not to use Himalayan salt when you're using when you want to create GANs from metals.
For metals.
Metal, you know, if you use copper, zinc, and iron, for example, then you should only apply sea salt water. Sea salt. Sorry.
I mean, sea salt water is with iodine in it.
OK， 他是说，如果我们用金属的那个来制作这种干丝的话，像什么铜干丝啊、铁啊或者锌，他说这个不要用喜马拉雅盐，应该用海盐。But I really made some GANs from Himalaya salt with copper, zinc, and iron. Yeah.
Why not? Why don't you use Himalayan salt with the metals?
The reason is because what we found many months ago is that people who have used a Himalayan salt, the results of the GANs are not good. You get different deformations. The sea salt is absolutely a winner when it comes to GANs with metals.
So maybe that's, Ruthie, that's why your GANs turn different colors when they're next to each other.
No, that GANs is bought from funds. Is not what I made. I bought from somebody. Yes. 所以那个 Torben 的意思是说，他说就是因为这个喜马拉雅盐，他们几个月前就是发现它会产生不同的长体，所以他觉得说可能当用金属干丝的时候，不要用喜马拉雅盐。
So if you're making GANs with the sea salt in metals, do you want the sea salt with iodine or without?
Yeah, so that's a problem. Yeah, people also
because the salt that you buy in the store has artificial iodine sprayed on it.
Yes.
Exactly.
And you don't usually want to make a GANs of that type of iodine.
Exactly.
That's why.
Yeah. And the Lion Zhang said that Mr. Keshe had said if we made GANs from the sea water, and it can't produce CO2 GANs. So is that true?
Mm-hmm. Yes, but there again, you have to verify the purity of the seawater, because whatever components are in the water, it turns it into GANs state.
Oh, you mean everything?
Everything. So if there happens to be chlorine or fluorine or petroleum particles or particles of whale poop or you name it that's in the ocean water, you'll make a GANs of it. Not necessarily, you don't want a GANs of all of that stuff unless you really know what you're doing.
他是说海水里面就任何这些东西跟海水放进去之后，它本身就会产生干丝，所以它海水里面含有各种的各样的这些东西啊，这种元素。But I mean the sea water is different with salt, right?
Well, yeah, there's different qualities of sea salt that you can buy or get. It depends on where they get the water from, because basically they take water from the ocean, evaporate it, and get the salt that's behind. So you're hoping, so you have to make sure that the quality of salt is, I don't know if it's organic or if they want to say that it's from a certain section of the sea. I don't know, but generally the sea salt that you buy is a pretty good pure quality.
You can say, Ruthie, in general, that the salty atmosphere has to do with the oxygen in the salt water during the GANs process. You see, you need a match more than a mix.
Sorry, I think could somebody help to translate? I'm a little bit, yeah. Feng, can you help to translate?
Yeah, Feng, you there?
Yeah, Feng, are you there?
What's that?
Yeah,
No?
I mean, I feel a little bit difficult to translate for this. Could you please translate for a while?
Oh,
Yeah.
sorry, I wasn't around. I can Chubon say it again.
Yes, Feng, the salty atmosphere in the air
在空气里面的海的盐的成分
has a match with the salt water from the GANS container.
has to match.
Yes.
但是他说就要配备那个在箱子里面的跟那个什么，哎呀，还是陆地还是你了，对不对？
Yes, sir.
Very important example is that when you use the salty atmosphere from the air,
当你使用空气中的这个盐的时候，
that's going to be the result when creating blood.
那个就是产生这个血液的结果。
That's how the water, oxygen in the water are loading itself with hydrogen instead of oxygen in the salt water.
那就是这个盐水中的氧如何吸收这个氢what?
It's passing the salty atmosphere, referring to the GANS, to the plasma in the air. The plasma in the air is using the salty atmosphere to find the combination in the sea water tank.
Really hard to understand. Yeah.
The response from the iron, the rusty iron, has a direct interference through the sink, but what is really going on in between the copper plate and the nano-coated plate and the sink is actually the air molecules with the salty atmosphere finding the salty water molecules.
在这个铜和锌之间，实际上发生的是和空气中的这个盐分，他们找到了盐分子。Oh God, I think it's really difficult for us to understand.
Tubiar, what's your point of getting across here? Because they were asking about the kind of Himalayan salt or table salt or evaporated sea salt to use to make the ganses, and then you come in with this stuff on.
Yes, the reason.
Can you make things simpler? Because I don't even know what you're saying.
Well, the first answer to the question about Himalaya salt, we talked about it.
We got that. So.
But the second answer is what Mr. Keshe is referring to. The game changer in this technology is when you realize that you're using the salty atmosphere, you're bringing the hydrogen, oxygen, and nitrogen into the salty atmosphere. You're bringing, you get a match with the salt water, and you create a blood. And this is why the amino acid. That's how the amino acid gets its strength. It's not from the oxygen; it's from the hydrogen.
So by using a salt in the evaporated sea salt, putting that in your distilled water to get your bath that you put your plates in, that's creating the environment that attracts the salt and all of the elements out of the air.
Yep.
Okay. So so by using the salt, the sea salt, because ultimately our own body's amino acids came from the sea way back when, you're creating a match there, or a
But,
Good morning, Clint. Good morning.
but guys, my question is, what's the difference between the seawater and the sea salt to make GANs, you know? Because people think that if we made GANs from the seawater, maybe you can't get what you want. Because the seawater, they have a lot of elements there, and he think if we use the sea salt, it's the same because sea salt is come out from the seawater. So what's that difference?
Well, the difference is that you don't have all the other elements there.
Already, when we have a sea salt, they get out that the elements. Yeah.
I don't know. To me, when you buy a high quality sea salt and you put that into distilled water, that resulting solution is going to be much more pure, much more clean, a more stable environment for the creation of CO2 and zinc GANs and whatever else GANs you're making, rather than walking out to the ocean, taking your pail, dipping the water out of the ocean, and then making your GANs out of that. They're two completely different solutions, because most of the time people are going to gather the ocean water from the shore. Yeah. And the shores have all of the different pollutions that wash out from the land, and the sewage and everything else that drains out from the landmass goes out 30, 40, 50 kilometers into the ocean before it gets filtered and cleaned up. So if you're going to actually use ocean seawater, the best place to get it is 50 to 100 kilometers from shore, and having the fishermen or having someone taking a bucket or something and lowering it down 300 meters, gather your water from 100 to 300 meters below the surface, and use that as your seawater.
Flint, you're losing Ruthie here.
Yeah, I'm here. Yeah. Okay, thank you, Flint.
Okay.
Yeah. 所以他Flint 是说他自己的经验，他如果买到高质量的这个海盐的话，出来这个水是非常的纯净的，就制造出来这个水的溶液啊，那肯定比你直接到这个一般都是在岸边去弄一点那个海水，那个各种生活污染啦、垃圾啦或者是什么其他的这些东西都在里面，所以如果要是取海水的话，也应该是离海岸边可能50公里、100公里那种，真的是比较干净的这个海。那当然我们可能不了解，就是说这个海水的这个制作过程是不是它已经把就海盐的制作过程是不是已经把这个海水里面一些不好的东西去掉了，或者说它仅只是晒干这么简单，但是基本上 I think most of people they make GANs with sea salt, right?
Yes. And also you can add, Ruthie, that the application is the most important thing.
Yeah, 所以就是你是做什么用，这是最重要的，而且可能大部分人至少他们都是在用海盐在制作干丝。Okay.
The important difference here is that if you want to make salt water out of fresh water, then you need sea salt GANs.
Okay, 所以
Right.
I think what it really means is that the dry salt is of meta state. The sea water salt is of a liquid state. So they think there must be a difference.
Exactly. The difference is that if you put sea salt in fresh water, you will have just that, fresh water with sea salt in. But if you want to make salt water out of fresh water, you need sea salt GANs to make it. It has to do with the water molecules. The fresh water molecules are not the same at all.
Just to be simple, is it because seawater is already in gas state, while the dried salt is not in gas state?
Exactly. So what is actually happening to the fresh water molecules is taking, it's a heritage of the memory with all the patterns of the salt water into the fresh water.
那他的意思就是说，海水呢已经是一个干湿的成分，那么晒干了的盐呢是一个污质的成分，就是这种区别，就是看你怎么用了。
Okay, I think that's explanation more workable, more trustable. Yeah. 好的，就是我觉得这个解释应该是更可接受一些。I think we already have our teaching became longer and longer.
I know we're at 4 hours here.
Yeah. I think we need to close it today. Yeah. Flink, could you send me the charting record so that I can pick up some question not answered next time, and continue our next meeting. Yeah.
Yeah.
非常抱歉，那个伟哲导这一次还是没有安排你的分享。下一次我们把你的分享就是直接放在前面，然后再做问题。好像一到回答问题的时候，就发现不停的有各种问题进来，然后就会很多的时间。然后也非常感谢您一直就是很愿意把您对这个就是这些经验值能够分享出来。OK， 所以现在就是我们会结束今天的这个课程。那么欢迎大家在下周六的同一时间，下午3点钟，欧洲的早上9点钟，继续来参与我们的中文的公开教学。也非常感谢 Flint， 感谢 Tobin 和 Monica， 还有 Jackie 的支持。那么也感谢我们来展示你们的 Margaret 系统的那包括感谢房子的提问，感谢阿基的这些问题，然后给我们的课程带来更多的这种互动。希望大家能够更活跃，让我们共同在一起快乐的学习，快乐的分享。好的，感谢大家。So thank you for everybody to attending for the first public teaching, and thank you for Flink, Tobin, Monica, and Jackie. Thank you for all of your great support, and thank you for all the people to have the wonderful questions and the presentation here. That's met next Saturday, the same time, 3 o'clock. Afternoon in Peking time, and CET time 9 o'clock in the morning. Thank you, everyone.
Thank you, Ruthie.
Thank you.
Thank you all.
Great work.
And thank you, Feng, for helping out translating.
Yeah, thank you, Feng. Yes. Please join with us all the time. I need your support.
You're wonderful, Feng. Thank you very much.
Thank you.
Yeah.
Bye for now.
Bye.
再见。